work, which has been now for hold for some years or 1 year or so. But we hope to continue and refresh our memories about and our work about it in near future, I hope. And then I will go through roughly what has happened during recent years in this area. Okay, so about the concept of space situational awareness. So at that time when we started this strategy work, it was kind of very much targeted to 3 different elements. So monitoring near-Earth objects, space weather, and then satellite surveillance and tracking. So these were the main elements in the ESA Space Safety Situational Awareness Program. And like we all know, so these are important matters. So there is plenty of important infra in space, which is affecting our everyday life. So it is important to understand in which kind of environment these infras are operated. And furthermore, it is important for us to be an active partner in SSA, because in Finland we have quite much widely appreciated expertise in this field. Okay, then I will kind of summarize briefly about the work which was done. So we started in 2017 around Christmas Day, just before Christmas. And yes, this was a bottom-up approach. And there were a team of about 10 to 20 people who were contributing to this activity. So some research institutes were there, National Land Survey and Finnish Met Institute. So I come from Finnish Met Institute. The universities were involved, so Aalto, Helsinki, Oulu, and Turku. The kind of the commercial sector was also Business Finland. Pauli Stigel was there in some meetings, and Isabel Juhani Huovelin was active in giving his comments as well. And then we also managed to get some representatives from the ministries in the discussions, and also some comments from Finnish Air Force. It is important to understand that in a country like Finland, it is nice to, when we build these systems, they will be most likely dual usage, so both civil and military interests are involved. And the result from this work was a document, this strategy document, and then we also composed 2 attachments to this document. So the other was kind of describing quite much in detail the ongoing activities related to space situational awareness on those days. And then also we made a list of actors in this field. And so we had meetings every now and then we kind of had the final kind of final push to get the documents ready in June 2020. And after that, this activity has been more or less on a hold. Here, with this slide, I'm showing some excerpts, parts of the document. First of all, you can see that the contents of the strategy document, you see that is roughly 12 pages long, so it's rather long document. And it is perhaps the most important thing there was these recommendations, which I will soon show you. And the recommendations were based on a SWOT analysis. You can see the SWOT analysis summarized on the right-hand side. But in addition to the recommendations, we also kind of tried to specify strategic objectives for all these 3 elements in SSA. And then also we put some lines about some ideas how a joint roadmap could be built in the future. Okay, so if we have a look on this SWOT analysis in more details, there are quite much of these things which are listed here. They are visible also in the recommendations, but I want to point out that there are, for example, these threats which are not maybe not so clearly visible there. For example, this difficulty to draw students to this area was recognized in 2017 or 18. I hope that we will future find a solution for this, because new intelligent students and early career scientists are needed in this field. Okay, I go forward. So then if you have a strategy, you need to have a vision as well. And the vision was defined first, and the vision was composed in very clear and concise statement. So Finland will have a comprehensive space situational awareness in 2030. That was the target for this activity. And then we drafted this type of a kind of a diagram how this service would look like. So the important part of it indeed, it will be a service near real time 24/7, but it has, of course, we cannot maintain such a service unless there is some very basic and important elements maintaining it. And of course, those basic elements will be these observations. So Finland has done very extensive investments to infrastructures that are supporting SSA observations, both ground-based and space-based. And Finland is now active also in building these small satellites or CubeSats. Of course, research is needed in many fields, and then observations need to be digested with these data analysis tools before they can be used in the services. So if we look at the collaborators or the users, so on national side, you can see that there are these very obvious ones, so ministries and contingency authorities, defense forces, satellite operators, we have them now in Finland, and commercial sector. And in the international side, we have, of course, EU and ESA, but also collaborators outside Europe, so NASA and US Spacecom and so on. So that was the vision. How to reach that vision, then of course a roadmap is needed, and the team made kind of 7 recommendations for the future kind of activities. 7 recommendations, like 7 brothers in this Alexis Kivi book. So here you can see those. So of course the money and resources, money is one important factor there. So more kind of coordinated investments are needed, more clear task division and mandates would be good to have. And then also commitments for maintaining these important infrastructures that we have for the valuable observations. And it will be important that this is a joint effort by commercial sector and academy. This is also good from the perspective of this new space ecology thinking, which is currently now very much discussed. And then it is not so that we just can inside Finland do this. We need to be very active also to EU and ESA, so to towards the European SSA services. And inside Finland, we need to enhance our communication among the 3 elements. And then the final recommendation is about putting up this really roadmap for implementation activities. So something about what has happened after 2020 when we kind of ended the first phase of this activity. So some positive signs have been there. So Finland has increased its contribution quite much in the ESA SSA program, which changed its name to Space Safety Program, and also in this context opened its scope quite much. So you can see that we are kind of almost with a factor of, let's say, 4 or so. We have increased our budget for the last phase. In Finland, we have kind of there was quite much discussion about the space agency in 2017 and 18. This kind of need has now at least partly solved by enhancing the role of the Finnish Space Committee. And this committee has now some working groups kind of supporting its work, coordination work, and one of these working groups is dedicated to SSA, which is good. So like you know, also EU has now become more active, and EU has its own EU space program. And this space program with its legislation mentions also SSA matters, but the budget there is not very extensive, but anyway, we are now in the European legislation. And EU has started to coordinate its activities also, so there are now some working groups, one for SST and the other for space weather. Now, it seems when I have participated to those working groups, it seems now that in SST, this SST partnerships of the big countries, which has been working now for some years for SST, they have a strong coordination role also in the future, but now the idea is to open this consortium to a more broader partnership, and Finland is currently working very, very actively to get the participation to this SST partnership. The working group for space weather was kind of started recently also, and now it seems that ESA will have there also. ESA with its space safety program and space weather element will have there a very strong role in order to put up the EU operational services as well. And of course, in Finnish research and development, things have evolved. So you saw just how Minna described the for sale targets and work. So that's one example. So also significant work has been done with the Metsähovi laser ranging kind of planning, and in Sodankylä there has been some new investments for research infrastructures and so on and so forth, just to give some examples. And this is my final slide of something about the future prospects. So yes, we want to continue this work, but I would now like to hear a bit more kind of views from the ministries how to continue. But the plan is to keep the same approach, so get people from academia and from commercial sectors, those who are really doing the development work, also involved in this strategy kind of upgrading, so to say, and updating. But I would first like to hear a bit more guidance from, for example, from the Finnish Space Committee, which parts should be sharpened in the current version, and which could be kind of perhaps get less emphasis if that is needed. And now, as this Finnish Space Committee has now these working groups, and all these working groups which I'm listing here, science and research, navigation, earth observation, security and business, all I believe they will have some interests towards SSA strategy. So it is good way to coordinate the activity in the future. Of course, we would need more funding for research, but also for the administrative work, which is always quite a burden in the EU and ESA collaboration. And it is now in EU and ESA, it is clear that these operational services, particularly in the EU side, they are targeted for SST and space weather. It is important that we don't forget the third element, so this NEO part also. So that is something which I wanted to highlight here as well.
Thank you very much, Kirsti. Yeah. I think we are starting to run out of the time. And in order to make this discussion a bit more lively, I would also ask for questions. If we have any questions, please think about the next question, but I also will tell you that we have 11:45 starting a session about SSA, space situational awareness and sustainable space, and we have very interesting proposals and talks, for example, about how to build Finnish National Space Situational Awareness Radar, and what other components possibly are involved in the sustainability approach here. But any questions to Kirsti?
Can I ask one question?
Of course.
I already actually put it into the chat, but Kirsti, can you elaborate, in your opinion, the kind of role of science of space weather in the future SSA operations? There are lots of things that are actually not known yet, so that they could be, reliably operated by a center, and especially in terms of the Earth's own space weather, the radiation belts, which are only partly driven by the solar variations. Thanks.
Okay, thank you, Minna. Yes, this is an important question, and indeed, science is needed, because in my view is that currently the space weather services are good in monitoring the current situation, so giving kind of at least some kind of global view of the activities. But on the side of forecasts, we are still very much behind behind that performance that we should have. And we cannot make any reliable forecasts unless we understand the processes. And therefore, the basic research in space weather is an important thing. And this radiation belt physics, indeed, that is very important, since, like there is quite much stuff in the geostationary orbit which are very critical. For example, in the EGNOS system has its which is supporting the Galileo system. It has some critical satellites on geostationary orbits, and it's important to understand if they will experience some problems.
Okay, thank you very much, Kirsti. Thank you very much, Minna. So I think, of course, science is needed, and Finnish is one of the top countries in space science area, and I really hope that it will stay in this way. And also our technology is catching up with all these needs, and as we see already, industry is having initiatives which could help us along on this way quite a bit. So, but thank you very much for this plenary session. Very important talks we had here, and now we start to prepare for the actual sessions of today. We have, as yesterday, three parallel tracks, which are starting 10:30 in 10 minutes. So Suvi is creating the rooms for these sessions, and we also have testing rooms where you can go and try out your presentation to see can you share your slides, and is your microphone working. So the first session after the break is going to be the Arctic and Boreal. This is going forward with the topic of yesterday. So Arctic and Boreal is a really big topic in Finland, as you can see. And we have very different talks about how to improve the satellite observations of carbon dioxide. We have talk about solar-induced fluorescence, satellite-based flood mapping, and also evaluation of snow density in a globe snow product. Then in a second breakout room, we will start a day-long session series, 3 sessions called Onboard Imaging. These sessions are very much about solar system and planetary science, different instruments, science and missions targeting to the solar system and studying solar system smaller objects like asteroids and comets. We have very highly ranked presenters in this track, really high quality track here. And then we have a very interesting new space flavored session about quality assurance and product assurance in this new space environment where we are getting cheaper satellites, faster made satellites. And for example, the first talk is coming from ISI, and Paavo will tell how ISI has been tackling the quality issues and how they have been creating a totally new lean system for quality and product assurance in a new space company. Marko Pudas will also tell about a new methods how to get rid of the tin whiskers, and we have also a talk about new space platforms which are cheaper and faster to make by Arnau Vidal. And then also an interesting and really growing aspect in quality assurance is the new technologies which allow to monitor the quality faster and deeper. And for this we have X-ray technologies presented by Miguel Sousa, and definitely an interesting track to take a look at. So we will start with the sessions in 5 minutes. If you have any questions now about the technical arrangements or anything, speak up at the moment, already now. And the rooms of the sessions are already open, so I recommend that everybody go to the sessions and start to prepare for the presentations. And here on the main track we're going to take a look on our sponsors and partners who are making this happening possible. You can reach me and the project team also anytime in the chat, or even email, or whatever is needed. As you all already noticed probably, we also have some of the slides uploaded to the system, so you can find some of the yesterday's slides already inside or embedded into the program on the home page. So if you are interested in taking a look to the slides of yesterday once again, you are welcome to go to the schedule and download the slides and take a look. Any questions, comments so far?
Where will the recordings be available and when?
This takes a bit of time, but we're recording all the sessions and then cleaning them up and trying to make them available. If recordings are coming available, they will come available to the homepage. So we will inform all the authors and registered participants, who are far more than 800 already, about recordings and material which is available on the conference site. Any other questions?
There's a question about the slide download. So slide download requires permission. Is this intended for the future?
No, it's not intended for the future. We are solving the technical problems. So as we do this kind of online conference for the very first time, so many things are actually coming as a surprise to us as well. But the important thing is that we have been starting to collect the slides. Adjusting the download rights is a minor issue which will be solved very soon.
Another question. I don't see the breakout rooms. I just have a pointer on my screen that wait to be assigned. So I should be hosting one of the breakout rooms, but I have
I see
trouble there.
all the breakout rooms. You just click away the message about assignment and just like go to your breakout room.
I don't, Jan.
I don't
see them.
either.
I don't see them.
That's
neither.
interesting. Suvi, are you online?
Either me.
Yes,
Neither.
they should be open. I don't know what's the issue.
I have in my Zoom on the lower panel just participants, chat, share screen, record, reactions. That's it.
Yeah.
No button for breakout rooms, no button for
I will
other
try
options.
to open them again.
Okay, I think this is a universal issue. So if you try to reopen them, maybe it goes away.
Yeah, it seems that we have some sort of... I see all the rooms.
Maybe it requires to relaunch.
I reopened them now. Do you see them now?
Not yet.
Not yet.
That's a really bad problem because it seems like I will try to do the same thing.
Now it's available.
It's
Now they
available
can.
now.
All right, sorry for the delay. I'm
Thank you
really
very much.
sorry.
Harp Technologies is a Finnish SME company providing technology and R&D services in the area of RF and microwave engineering. Our customers are system integrators, equipment suppliers, research institutes, the European Space Agency, and defense forces. We help our customers to develop innovative and competitive products, and we develop methods and technology to acquire critical measurement data. Our customers operate in the domains of space, defense and security, remote sensing, and IoT and telecom. Our activities are organized into 4 business lines: microwave sensors, microwave components, signal processing, and electromagnetics. In what follows, we present some sample equipment that we have developed for our customers. Within our microwave sensor business line, we develop radars and passive sensors and their subsystems for space, defense, and remote sensing. As an example, here is a passive sensor. a microwave radiometer. Radiometers are useful for various remote sensing applications. Within our microwave components business line, we design and develop components according to customer specifications. Here is one example, a low-loss ferrite switch. On the right, you can see how the switch works. The signal is first directed into one port, and after switching, into the other port. Within our signal processing business lines, we develop algorithms and technology to improve the performance of microwave sensors. As an example, here is a signal processor to detect and filter out radio frequency interference. The antenna is the key component in many radio frequency systems. Within our electromagnetics business line, we develop antennas for various applications. Here is one example, an antenna for the radar altimeter of a planetary lander. Harp Technologies provides technology and R&D services in RF and microwave engineering within 4 business lines. We support our customers in various application domains. Harp Technologies, at your service.
The evolution of technology, like, it doesn't happen automatically. The evolution of technology and evolution of humanity, only happens if somebody does something about it. When you look at space technology as a whole, it's very easy to see that as the sort of next frontier of technology, next frontier of humanity.
The globe has always been on the move. Until now, we really haven't been able to capture that continuous change that keeps on going in front of our eyes. ICEYE has developed a completely unique technology. It's a synthetic aperture radar system mounted on a small satellite and allows us to see through clouds and darkness any place around the globe. And that sort of data stream was unavailable before. The persistent monitoring that is available with ICEYE's technology it's the first truly global ability to look at things on daily and sometimes sub-daily basis. We can have hundreds of locations being imaged every 12, every 8, every 4, 5, 6 hours, and we can get that data stream to us continuously.
If you go from the scale of weeks to days or weeks to hours, you are enabling the idea, oh my God, for the first time, we're actually looking at potentially predicting avalanches, potentially predicting volcano eruptions, predicting massive earthquakes, predicting building collapses before they happen.
You can't allow the ability to miss what's going on. How could we ever build a reliable flood monitoring system if we couldn't guarantee the ability to measure the water depth, regardless of what's happening on the ground? What if we missed a flood? Then our system is worthless.
This is why we wanted to bring available what's called coherent ground track repeat. And we wanted to make it daily so that every day you can get a repeating ground track image acquisition on the same location that allows you to do these millimeter level change detection on every 24-hour basis.
It's a new way to observe the life on Earth because it's the first time that really we can reach anywhere and anytime.
As a leading space technology and intelligence company, Maxar helps customers unlock the promise of space to solve problems on Earth and beyond. Whether it's collecting geospatial data to help organizations build reliable maps for their consumers, providing the intelligence governments need for national security and sound decision-making, or building spacecraft components that will send the next astronauts to the moon and beyond. Our capabilities in space infrastructure and Earth intelligence turn big ideas into successful missions.
We have been on the far side of the moon. We have explored a comet and been in orbit around Mars. Today we are on our way to both Mercury and the Sun, and will soon begin our journey to Jupiter and 3 of its icy moons. At IRF in Kiruna, we have been developing instruments for space missions for over 60 years, and in that time, much has changed. The space industry is now open to many more stakeholders and is expected to grow rapidly over the next few decades. There is an increasing need to test and calibrate new space technology, and that is exactly what IRF Space Lab can provide. Space Lab is a constantly expanding facility with the aim of continuing to be in the forefront and to develop according to the growing market. As a step in this process, we want to broaden our network of customers and partners and share with them our knowledge, passion, and ambitions. Take the step out into space with us.
Space and its technology continue being a key element in our society development despite COVID. At both EAST and European Union, there are many missions directed to improve human being lives. Europe recently had its largest budget ever approved since its history, and there are a huge number of missions like Copernicus, Ariel, directed to explore exoplanets, and many others. Other countries such as United States continue investing huge amounts in projects such as Starlink, NASA supporting and leading many different missions, customers like Boeing, and many other organizations that are recurrent customers to Alter.
So, Alter Technology, we have recently developed multiple self-service digital tools for our customers. So the most relevant one is a digital database for EEE parts that is based on big data technology. And then we have two digital tools that are intended for the customers to follow up on their purchase orders. Okay, so the first one allows them to check the whole procurement process so they can see information related to their logistics, the finances as well, and all the documentation of their orders. And then the second one allows the customers to perform the real-time monitoring of the testing activities. Then recently, we have developed a virtual platform, a consultancy platform that is intended for consultancy services. So then the users can send us their consultation requests for us to address them and give them the best solution.
Communication systems have become a key element in today's world where virtual events and virtual meetings take place worldwide. High-speed digital systems, microwaves, and optics systems merge together to meet the requirements of a growing demand for high-capacity links. Alter Technology combines its expertise areas to meet the requirements of future communication systems.
So space continues being in the trend, and Alter is just there.
The world is slipping into post-factual existence. It's easy to make assumptions, take action, and go wrong.
I think there is no climate change at all.
I'm pretty sure I'll stop global warming if I stop using plastic bags.
I don't think there's such a thing as responsible forest management.
I'm not sure, but I think my food is produced organically.
Polarization of issues happen because of assumptions. We are on a mission against that. The technology we use monitors the environment from space. We collect and combine facts that you can use to start action. Our range of experts leverage creative technology to make an impact on things that really matter. Stop assuming. Try facts with us.
DA Group is a technology company. We have been in space business about 40 years. We provide advanced electronics and radio frequency solutions and products for major space companies on a global scale. DA Group delivers equipment and subsystems for space applications, including all phases of development, design, manufacturing, and testing. We maintain strong prototype and in-house design. This enables us to provide unique and complex systems for the space applications. Currently we are building systems for more than 10 satellites. We have a large clean room that enables us to provide large-scale manufacturing on the small satellites in series. Our aim is to make space everybody's business.
Tällä hetkellä avaruudestahan on tulossa ihan kansainvälinen megatrendi. Ja koska sinne lähetetään uusia satelliitteja niin paljon, niin on myöskin tärkeää varmistaa, että sen avaruuden käyttäminen säilyy turvallisena. Me kehitetään semmoista uutta radalta poistoteknologiaa. Toisaalta me halutaan, että näiden satelliittien käyttöikä pitenisi. Ja tässä kaikkein tärkein tekijä on avaruuden säteilyympäristö. Satelliitti ikääntyy siellä ja voi ihan jopa kuollakin. Ja me sitten tutkitaan sitä säteilyä ja kehitetään uudenlaisia menetelmiä suojautua siltä säteilyltä. Huippuyksikön taustahan on itse asiassa Euroopan unionissa, missä mä istuin monta vuotta semmoisessa komiteassa, joka miettii Euroopan tulevaisuutta ja avaruutta. Ja sitten kun tämä tilaisuus tuli tähän huippuyksikön hakemiseen, niin mä itse asiassa kokosin sitten maailman parhaat osaajat, jotka sattumoisin oli Suomessa. Mehän ollaan tässä nostamassa ylös Suomen ensimmäinen tieteellinen avaruusohjelma. Ja jos me tehtäisiin tämä sillä tavalla, kun yleensä avaruusohjelmia tehdään, niin tässä menisi 30 vuotta. Mutta nyt kun me käytetään näitä uusia teknologioita ja piensatelliitteja, niin me toivotaan itse asiassa pääsevämme tähän täysmittaisen avaruusohjelman rakentamiseen vain 8 vuodessa. Ja koska kuitenkin puhutaan näin pitkästä ajasta, niin on tärkeää, että on tämmöinen pitkäjänteinen rahoitus tässä taustalla. Jos ajatellaan vaikkapa kommunikaatio, niin suuri osa siitä perustuu satelliittien signaaleihin, samoin navigaatio. Eli nyt tämän avaruuden kestävän hyötykäytön kannalta on tärkeää, että nämä radat pysyy käytettävinä myöskin tulevaisuudessa. Eli tämä olisi se kaikkein tärkein asia, mitä me halutaan saavuttaa.
The evolution of technology, like, it doesn't happen automatically. The evolution of technology and evolution of humanity, only happens if somebody does something about it. When you look at space technology as a whole, it's very easy to see that as the sort of next frontier of technology, next frontier of humanity.
The globe has always been on the move. Until now, we really haven't been able to capture that continuous change that keeps on going in front of our eyes. ICEYE has developed a completely unique technology. It's a synthetic aperture radar system mounted on a small satellite and allows us to see through clouds and darkness any place around the globe. And that sort of data stream was unavailable before. The persistent monitoring that is available with ICEYE's technology it's the first truly global ability to look at things on daily and sometimes sub-daily basis. We can have hundreds of locations being imaged every 12, every 8, every 4, 5, 6 hours, and we can get that data stream to us continuously.
If you go from the scale of weeks to days or weeks to hours, you are enabling the idea, oh my God, for the first time, we're actually looking at potentially predicting avalanches, potentially predicting volcano eruptions, predicting massive earthquakes, predicting building collapses before they happen.
You can't allow the ability to miss what's going on. How could we ever build a reliable flood monitoring system if we couldn't guarantee the ability to measure the water depth regardless of what's happening on the ground? What if we missed a flood? Then our system is worthless.
This is why we wanted to bring available what's called coherent ground track repeat, and we wanted to make it daily so that every day you can get a repeating ground track image acquisition on the same location that allows you to do these millimeter level change detection on every 24-hour basis.
It's a new way to observe the life on Earth because it's the first time that really we can reach anywhere and anytime.
BA Group is a technology company. We have been in space business about 40 years. We provide advanced electronics and radio frequency solutions and products for major space companies on a global scale. BA Group delivers equipment and subsystems for space applications, including all phases of development, design, manufacturing, and testing. We maintain strong prototype and in-house design. This enables us to provide unique and complex systems for the space applications. Currently, we are building systems for more than 10 satellites. We have a large clean room that enables us to provide large-scale manufacturing of the small satellites in series. Our aim is to make space everybody's business.
The world is slipping into post-factual existence. It's easy to make assumptions, take action, and go wrong.
I think there is no climate change at all.
I'm pretty sure I'll stop global warming if I stop using plastic bags.
I don't think there's such a thing as responsible forest management.
I'm not sure, but I think my food is produced organically.
Polarization of issues happen because of assumptions. We are on a mission against that. The technology we use monitors the environment from space. We collect and combine facts that you can use to start action. Our range of experts leverage creative technology to make an impact on things that really matter. Stop assuming. Try facts with us.
For many, it's the sense of freedom while soaring far above the Earth with the horizon the only boundary. But for me, it is something very different, the fascination of landing. When the Earth draws closer and closer, when the distant vision resolves into finer structures and vague outlines become distinct features, when ever smaller details are revealed to the eye. But in the world of the very small, where the human eye is no longer enough, we enter the domain of X-ray and CT technology. Here we make things visible that are 200 times finer than a human hair. Precision is paramount in the inspection of parts and materials, in their exact measurements. Minute defects can have big consequences for the safety of components. That's why every truck tire is X-rayed to make sure it's roadworthy. And every turbine blade intended for jet engines is examined inside and out. Our technology is used to screen the luggage of millions of passengers. And soon this inspection will also quickly and reliably identify what types of fluids travelers are carrying. This is where my colleagues and I are working to invent the future. A key trend in many industries is miniaturization. Far beyond where conventional measurement methods reach their limits, our computed tomography opens up undreamt of possibilities. We deliver razor-sharp 3D views of even the tiniest parts. All details can be measured with the highest precision and compared with CAD drawings, for example. Especially in the fast-changing world of electronic components, wherever greater performance must be packed into smaller and smaller devices. Our X-ray and CT solutions are integral to assuring that every part will be able to perform as specified. A crucial element in all this is the software. The best image quality is only made possible by highly complex algorithms. Yet for the user, the equipment is as easy and intuitive to operate as a smartphone. In the automotive industry, the limits of the possible are constantly redefined. And that begins right in the research labs, where new materials and manufacturing methods are tested. The tailor-made inspection and measurement solutions that I develop together with customers help optimize their processes, make their production more reliable, and save resources. No company can afford to design or deliver faulty products. It makes me proud to know that the largest and most successful companies in the world rely on our technology. Whether it's in the automotive sector or the aerospace industry, in electronics or medical equipment, the applications are practically endless. Seeing everything that's already made possible by our X-ray and CT solutions, I'm excited for the future. I'm eager to see what new worlds our technology will bring into focus next.
Interference-free satellite positioning is vital for the critical functions of society. Our researchers have developed a public GNSS signal quality monitoring service, GNSS Finland. This state-of-the-art system produces data that can be integrated to other situational awareness systems. Want to know more? Join us at our virtual meeting room.
We are living in a connected world. We are operating in a global economy. We are embracing digitalization in a fast-paced society. Communication, mobility, security, science.
So, hello everybody, and welcome back to the small break. As we look on the schedule, the next... I seem to be wrong. I hope... Yes, we are still ongoing with the last presentation on the breakout room, so sorry, wrong alert. The last presentation just started and we will meet here 11:30 and enjoy the session so far. And I ask also everybody to close your mics. There is some kind of sound which is dripping to the feed at the moment.
Our activities are organized into 4 business lines: microwave sensors, microwave components, signal processing, and electromagnetics. In what follows, we present some sample equipment that we have developed for our customers. Within our microwave sensor business line, we develop radars and passive sensors and their subsystems for space, defense, and remote sensing. As an example, here is a passive sensor, a microwave radiometer. Radiometers are useful for various remote sensing applications. Within our microwave components business line, we design and develop components according to customer specifications. Here is one example, a low-loss ferrite switch. On the right, you can see how the switch works. The signal is first directed into one port, and after switching, into the other port. Within our signal processing business lines, we develop algorithms and technology to improve the performance of microwave sensors. As an example, here is a signal processor to detect and filter out radio frequency interference. The antenna is the key component in many radio frequency systems. Within our electromagnetics business line, we develop antennas for various applications. Here is one example, an antenna for the radar altimeter of a planetary lander. Harp Technologies provides technology and R&D services in RF and microwave engineering within 4 business lines. We support our customers in various application domains. Harp Technologies, at your service.
Space and its technology continue being a key element in our society development despite COVID. At both East and European Union, there are many missions directed to improve human being lives. Europe recently had its largest budget ever approved since its history, and there are a huge number of missions like Copernicus, Ariel, directed to explore exoplanets, and many others. Other countries such as United States continue investing huge amounts in projects such as Starlink, NASA supporting and leading many different missions, customers like Boeing, and many other organizations that are recurrent customers to Alter.
So Alter Technology, we have recently developed multiple self-service digital tools for our customers. So the most relevant one is a digital database for EEE parts that is based on big data technology. And then we have two digital tools that are intended for the customers to follow up on their purchase orders. Okay, so the first one allows them to check the whole procurement process so they can see information related to their logistics, the finances as well, and all the documentation of their orders. And then the second one allows the customers to perform the real-time monitoring of the testing activities. Then recently, we have developed a virtual platform, a consultancy platform that is intended for consultancy services. So then the users can send us their consultation requests for us to address them and give them the best solution.
Communication systems have become a key element in today's world where virtual events and virtual meetings take place worldwide. High-speed digital systems, microwaves, and optics systems merge together to meet the requirements of a growing demand for high-capacity links. Alter Technology combines its expertise areas to meet the requirements of future communication systems.
So space continues being in the trend, and Alter is just there.
As a leading space technology and intelligence company, Maxar helps customers unlock the promise of space to solve problems on Earth and beyond. Whether it's collecting geospatial data to help organizations build reliable maps for their consumers, providing the intelligence governments need for national security and sound decision-making, or building spacecraft components that will send the next astronauts to the moon and beyond. Our capabilities in space infrastructure and Earth intelligence turn big ideas into successful missions.
Time and time again, people have been gazing up at the night sky, looking for understanding and answers. But what if the answers might actually lie in the constellations staring back at us? Hundreds of kilometers away, small satellite constellations observe the whole wide world. Despite the distance, these satellites can be harnessed to satisfy our need for instant, reliable information and to benefit everyday life on Earth. Everything from national security to nature monitoring can be improved with space technology. We can now use remote sensing for blue-green algae monitoring in near real time, or rely on satellites to provide fast and robust communications during national security emergencies. At VTT, we believe space technology to be the answer to many of the pressing issues we face today. That's why for decades now, we've been working in space innovation together with our key partners, such as the European Space Agency. We have created the world's first hyperspectral cameras for small satellites and the first W-band millimeter wave radios operating in space. For us, it's not just about exploring what's out there. Our bold vision is to make space technology an integral part of the day-to-day life on Earth, with technologies like beyond 5G, hyperspectral imaging, and Earth observation. Want to join us in making a difference on Earth and beyond?
Hello again. We are approaching now the end of the session, and as you see here from the schedule, next sessions will start in 15 minutes. So I hope. Okay, so we just gave some more time to the sessions. And let's wait a bit more then, as we started a bit late because there was a trouble of creating accessible sessions. So we will steal this time from the break buffer. Is there anybody in the main room at the moment? Just to check the sound and.
Yes, Jan, everything is fine.
Excellent. Very good. Yeah, sometimes it's a bit a lonely work here, because usually I do not hear anybody else and I don't even hear myself. So I'm just
yes.
hoping and being confident that everything is streamed and going better. Is the sound better today?
Yes, it is good. It used to be a little bit more distant, but I guess you have now a mic closer to your mouth.
Yeah, actually, I was like finding the settings from Windows, which was turning down my mic. So I put it back to the 100%, and now it works as it should.
It's very good.
Yeah. So you are waiting for another industry hour, I presume.
Well, yeah, that too. There are also interesting sessions and also my own presentation of, but not very soon.
Okay.
It's in the payloads.
All right. So we have still a bit to wait as we will get back all the people from different rooms. So whoever just joined the conference, so we are still waiting the sessions to end. We started a bit late with the sessions, and that's why we gave them a bit more time to wrap up everything. But very soon we wait everybody back to the main session, having a small break, taking a look what is happening during the next sessions, and then having next sessions. So hello Yuval, hello Jenny. Can I assume that the sessions are starting to end now?
I'm assuming that the next session will start, so that I can start my presentation that I didn't test beforehand.
Yeah,
So
just to update. Yeah, to update you, we have also the testing rooms. So there is a testing room still open, but I presume that the sessions will go close very soon, and so also the testing sessions. But if you join your session early, then you have a little bit of time, around 5 minutes, to try it out.
Yeah, that's what I was planning to do. Samsa, säkin oot siellä vai kuulolla?
Yes.
I tried to do the testing room, but it seems that I did not enter there.
Yeah. So we closed all the rooms at the moment. So welcome back to the main track. Who are at the main track? I was thinking I heard Sampsa here.
Yes, I'm here.
Excellent. So I think we should take a look now to the next sessions. And the next sessions will start 11:45, not so many minutes left to the session beginning. And we're going to have sessions Earth observation and artificial intelligence. We have many very interesting presentations there. We have Jenni Attila, Sanna Härkönen, Akpo Siemuri and Juha Karvonen. Juha actually sent a video file because he was not able to attend this particular moment of time. And there are various topics of using artificial intelligence and neural networks for SAR images and optical images. Then we have another session in onboard imaging.
If I can stop you for a while.
Yes, you can.
The starting of the presentation of Juha Karvonen.
Yeah, it's Juha's presentation is, we have it, and Juha's presentation will be played as a video file, and you will have a presentation.
Yeah, but who will do that? You handle that?
Suvi will present the file.
Oh, okay, good, thanks.
Then onboard imaging will go on as well. We have Neil Bowles telling about Mirmis instrument. Then we have Altti Akujärvi from VTT telling about Mirmis developments at VTT. Robert Strops is going to tell about spectral imagers for asteroids. And Josep Kivastik will tell activities on payload developments at Tartu Observatory. And then we have already advertised space situational awareness and sustainable space session with a couple of presentations about Finnish national space situational awareness radar. There is Nestori Fabritius from DA Design who is going to give a presentation. No, sorry, I was changing the slide too far already. And Sari Lasanen going to also tell about Finnish radar. Eija Tanskanen will give an overview of Earth-space ecosystem, which enables also sustainability and awareness of what's happening. And Vipul will give a presentation about CubeSat deorbiting and considerations of sustainability of CubeSats in space. So these are the sessions which will come up now. They are Earth observation and artificial intelligence, onboard imaging in solar system missions, will continue, and space situational awareness and sustainability will also start soon. Any comments, problems which we could solve at the moment? We were also noticing that there is a small permission conflict in order to view all the slides which you have been uploading. We have been changing most of the permissions already so everybody can view them, but we are dealing with a technical problem, and soon every link on the homepage will be accessible. And there was also a problem that we allowed everybody to upload just one file. So a couple of people tried to upload a second version of the same file, and of course the system said like you exceeding the limits of the uploads. We are adding a couple of more possibilities there, so people can change their upload and upload updated slides if needed. So just wait a moment and we'll have this issue solved as well. So the rooms are already opened. Am I right, Sari? Satu, sorry. Suvi,
Yes, the
I'm
rooms are open.
mixing up. Yeah, the rooms are open, so we are able to start with the sessions. I hope everybody will go to the sessions. You still have 3 minutes to test your slides and see how it works. And here on the main channel, we'll go back to our sponsor videos and logos and see what industry in this area is doing. And also next up after this session, we're starting with industry hour. And during industry hour, we have a dense program, interviews with different industry representatives whom you can also meet online in breakout rooms. So have a nice sessions and see you soon, approximately in 1 hour here in the main channel. So have a nice sessions.
As a leading space technology and intelligence company, Maxar helps customers unlock the promise of space to solve problems on Earth and beyond. Whether it's collecting geospatial data to help organizations build reliable maps for their consumers, providing the intelligence governments need for national security and sound decision-making, or building spacecraft components that will send the next astronauts to the moon and beyond. Our capabilities in space infrastructure and Earth intelligence turn big ideas into successful missions.
We have been on the far side of the moon.
We have explored a comet and been in orbit around Mars. Today we are on our way to both Mercury and the Sun, and will soon begin our journey to Jupiter and 3 of its icy moons. At IRF in Kiruna, we have been developing instruments for space missions for over 60 years, and in that time, much has changed. The space industry is now open to many more stakeholders and is expected to grow rapidly over the next few decades. There is an increasing need to test and calibrate new space technology, and that is exactly what IRF Space Lab can provide. Space Lab is a constantly expanding facility with the aim of continuing to be in the forefront and to develop according to the growing market. As a step in this process, we want to broaden our network of customers and partners and share with them our knowledge, passion, and ambitions. Take the step out into space with us.
Space and its technology continue being a key element in our society development despite COVID. At both East and European Union, there are many missions directed to improve human being lives. Europe recently had its largest budget ever approved since its history, and there are a huge number of missions like Copernicus, Ariel, directed to explore exoplanets, and many others. Other countries such as United States continue investing huge amounts in projects such as Starlink, NASA supporting and leading many different missions, customers like Boeing, and many other organizations that are recurrent customers to Alter.
So, Alter Technology, we have recently developed multiple self-service digital tools for our customers. So the most relevant one is a digital database for EEE parts that is based on big data technology. And then we have two digital tools that are intended for the customers to follow up on their purchase orders. Okay, so the first one allows them to check the whole procurement process so they can see information related to their logistics, the finances as well, and all the documentation of their orders. And then the second one allows the customers to perform the real-time monitoring of the testing activities. Then recently, we have developed a virtual platform, a consultancy platform that is intended for consultancy services. So then the users can send us their consultation requests for us to address them and give them the best solution.
Communication systems have become a key element in today's world where virtual events and virtual meetings take place worldwide. High-speed digital systems, microwaves, and optics systems merge together to meet the requirements of a growing demand for high-capacity links. Alter Technology combines its expertise areas to meet the requirements of future communication systems.
So space continue being in the trend, and Alter is just there.
The world is slipping into post-factual existence. It's easy to make assumptions, take action, and go wrong.
I think there is no climate change at all.
I'm pretty sure I'll stop global warming if I stop using plastic bags.
I don't think there's such a thing as responsible forest management.
I'm not sure, but I think my food is produced organically.
Polarization of issues happen because of assumptions. We are on a mission against that. The technology we use monitors the environment from space. We collect and combine facts that you can use to start action. Our range of experts leverage creative technology to make an impact on things that really matter. Stop assuming. Try facts with us.
DA Group is a technology company. We have been in space business about 40 years. We provide advanced electronics and radio frequency solutions and products for major space companies on a global scale. DA Group delivers equipment and subsystems for space applications, including all phases of development, design, manufacturing, and testing. We maintain strong prototype and in-house design. This enables us to provide unique and complex systems for the space applications. Currently we are building systems for more than 10 satellites. We have a large clean room that enables us to provide large-scale manufacturing on the small satellites in series. Our aim is to make space everybody's business.
Tällä hetkellä avaruudestahan on tulossa ihan kansainvälinen megatrendi. Ja koska sinne lähetetään uusia satelliitteja niin paljon, niin on myöskin tärkeää varmistaa, että sen avaruuden käyttäminen säilyy turvallisena. Me kehitetään semmoista uutta radalta poistoteknologiaa. Toisaalta me halutaan, että näiden satelliittien käyttöikä pitenisi. Ja tässä kaikkein tärkein tekijä on avaruuden säteilyympäristö. Satelliitti ikääntyy siellä ja voi ihan jopa kuollakin. Ja me sitten tutkitaan sitä säteilyä ja kehitetään uudenlaisia menetelmiä suojautua siltä säteilyltä. Huippuyksikön taustahan on itse asiassa Euroopan unionissa, missä mä istuin monta vuotta semmoisessa komiteassa, joka miettii Euroopan tulevaisuutta ja avaruutta. Ja sitten kun tämä tilaisuus tuli tähän huippuyksikön hakemiseen, niin mä itse asiassa kokosin sitten maailman parhaat osaajat, jotka sattumoisin oli Suomessa. Mehän ollaan tässä nostamassa ylös Suomen ensimmäinen tieteellinen avaruusohjelma. Ja jos me tehtäisiin tämä sillä tavalla, kun yleensä avaruusohjelmia tehdään, niin tässä menisi 30 vuotta. Mutta nyt kun me käytetään näitä uusia teknologioita ja piensatelliitteja, niin me toivotaan itse asiassa pääsevämme tähän täysmittaisen avaruusohjelman rakentamiseen vain 8 vuodessa. Ja koska kuitenkin puhutaan näin pitkästä ajasta, niin on tärkeää, että on tämmöinen pitkäjänteinen rahoitus tässä taustalla. Jos ajatellaan vaikkapa kommunikaatioon, niin suuri osa siitä perustuu satelliittien signaaleihin, samoin navigaatio. Eli nyt tämän avaruuden kestävän hyötykäytön kannalta on tärkeää, että nämä radat pysyvät käytettävinä myöskin tulevaisuudessa. Eli tämä olisi se kaikkein tärkein asia, mitä me halutaan saavuttaa.
The evolution of technology, like, it doesn't happen automatically. The evolution of technology and evolution of humanity, only happens if somebody does something about it. When you look at space technology as a whole, it's very easy to see that as the sort of next frontier of technology, next frontier of humanity.
The globe has always been on the move. Until now,
We really haven't been able to capture that continuous change that keeps on going in front of our eyes. ICEYE has developed a completely unique technology. It's a synthetic aperture radar system mounted on a small satellite and allows us to see through clouds and darkness any place around the globe. And that sort of data stream was unavailable before. The persistent monitoring that is available with ICEYE's technology it's the first truly global ability to look at things on daily and sometimes sub-daily basis. We can have hundreds of locations being imaged every 12, every 8, every 4, 5, 6 hours, and we can get that data stream to us continuously.
If you go from the scale of weeks to days or weeks to hours, you are enabling the idea of, oh my God, for the first time, we're actually looking at potentially predicting avalanches, potentially predicting volcano eruptions, predicting massive earthquakes, predicting building collapses before they happen.
You can't allow the ability to miss what's going on. How could we ever build a reliable flood monitoring system if we couldn't guarantee the ability to measure the water depth regardless of what's happening on the ground? What if we missed a flood? Then our system is worthless.
This is why we wanted to bring available what's called coherent ground track repeat. And we wanted to make it daily so that every day you can get a repeating ground track image acquisition on the same location that allows you to do these millimeter level change detection on every 24-hour basis.
It's a new way to observe the life on Earth because it's the first time that really we can reach anywhere and anytime.
DA Group is a technology company. We have been in space business about 40 years. We provide advanced electronics and radio frequency solutions and products for major space companies on a global scale. DA Group delivers equipment and subsystems for space applications, including all phases of development, design, manufacturing, and testing. We maintain strong prototype and in-house design. This enables us to provide unique and complex systems for the space applications. Currently, we are building systems for more than 10 satellites. We have a large clean room that enables us to provide large-scale manufacturing on the small satellites in series. Our aim is to make space everybody's business.
The world is slipping into post-factual existence. It's easy to make assumptions, take action, and go wrong.
I think there is no climate change at all.
I'm pretty sure I'll stop global warming if I stop using plastic bags.
I don't think there's such a thing as responsible forest management.
I'm not sure, but I think my food is produced organically.
Polarization of issues happen because of assumptions. We are on a mission against that. The technology we use monitors the environment from space. We collect and combine facts that you can use to start action. Our range of experts leverage creative technology to make an impact on things that really matter. Stop assuming. Try facts with us.
For many, it's the sense of freedom while soaring far above the Earth with the horizon the only boundary. But for me, it is something very different, the fascination of landing. When the Earth draws closer and closer, when the distant vision resolves into finer structures and vague outlines become distinct features, when ever smaller details are revealed to the eye. But in the world of the very small, where the human eye is no longer enough, we enter the domain of X-ray and CT technology. Here we make things visible that are 200 times finer than a human hair. Precision is paramount in the inspection of parts and materials, in their exact measurements. Minute defects can have big consequences for the safety of components. That's why every truck tire is X-rayed to make sure it's roadworthy. And every turbine blade intended for jet engines is examined inside and out. Our technology is used to screen the luggage of millions of passengers, and soon this inspection will also quickly and reliably identify what types of fluids travelers are carrying. This is where my colleagues and I are working to invent the future. A key trend in many industries is miniaturization. Far beyond where conventional measurement methods reach their limits, our computed tomography opens up undreamt of possibilities. We deliver razor-sharp 3D views of even the tiniest parts. All details can be measured with the highest precision and compared with CAD drawings, for example. Especially in the fast-changing world of electronic components, wherever greater performance must be packed into smaller and smaller devices. Our X-ray and CT solutions are integral to assuring that every part will be able to perform as specified. A crucial element in all this is the software. The best image quality is only made possible by highly complex algorithms. Yet for the user, the equipment is as easy and intuitive to operate as a smartphone. In the automotive industry, the limits of the possible are constantly redefined. And that begins right in the research labs, where new materials and manufacturing methods are tested. The tailor-made inspection and measurement solutions that I develop together with customers help optimize their processes, make their production more reliable, and save resources. No company can afford to design or deliver faulty products. It makes me proud to know that the largest and most successful companies in the world rely on our technology. Whether it's in the automotive sector or the aerospace industry, in electronics or medical equipment, the applications are practically endless. Seeing everything that's already made possible by our X-ray and CT solutions, I'm excited for the future. I'm eager to see what new worlds our technology will bring into focus next.
Interference-free satellite positioning is vital for the critical functions of society. Our researchers have developed a public GNSS signal quality monitoring service, GNSS Finland. This state-of-the-art system produces data that can be integrated to other situational awareness systems. Want to know more? Join us at our virtual meeting room.
We are living in a connected world. We are operating in a global economy. We are embracing digitalization in a fast-paced society. Communication, mobility, security, science.
Liftoff.
Life on Earth advances. thanks to space technology. RUAG Space is the partner of choice for manufacturers of satellites and launchers across the globe, enabling society to prosper, advancing everyday life. Today and tomorrow, we make it happen.
Harp Technologies is a Finnish SME company providing technology and R&D services in the area of RF and microwave engineering. Our customers are system integrators, equipment suppliers, research institutes, the European Space Agency and defense forces. We help our customers to develop innovative and competitive products, and we develop methods and technology to acquire critical measurement data. Our customers operate in the domains of space, defense and security, remote sensing, and IoT and telecom. Our activities are organized into 4 business lines: microwave sensors, microwave components, signal processing, and electromagnetics. In what follows, we present some sample equipment that we have developed for our customers. Within our microwave sensor business line, we develop radars and passive sensors and their subsystems for space, defense, and remote sensing. As an example, here is a passive sensor, a microwave radiometer. Radiometers are useful for various remote sensing applications. Within our microwave components business line, we design and develop components according to customer specifications. Here is one example, a low-loss ferrite switch. On the right, you can see how the switch works. The signal is first directed into one port, and after switching, into the other port. Within our signal processing business lines, we develop algorithms and technology to improve the performance of microwave sensors. As an example, here is a signal processor to detect and filter out radio frequency interference. The antenna is the key component in many radio frequency systems. Within our electromagnetics business line, we develop antennas for various applications. Here is one example, an antenna for the radar altimeter of a planetary lander. Harp Technologies provides technology and R&D services in RF and microwave engineering within 4 business lines. We support our customers in various application domains. Harp Technologies, at your service.
Space and its technology continue being a key element in our society development despite COVID. At both East and European Union, there are many missions directed to improve human being lives. Europe recently had its largest budget ever approved since its history, and there are a huge number of missions like Copernicus, Ariel, directed to explore exoplanets, and many others. Other countries such as United States continue investing huge amounts in projects such as Starlink, NASA supporting and leading many different missions, customers like Boeing, and many other organizations that are recurrent customers to Alter.
So at Alter Technology, we have recently developed multiple self-service digital tools for our customers. So the most relevant one is a digital database for EEE parts that is based on big data technology. And then we have two digital tools that are intended for the customers to follow up on their purchase orders. Okay, so the first one allows them to check the whole procurement process so they can see information related to their logistics, the finances as well, and all the documentation of their orders. And then the second one allows the customers to perform the real-time monitoring of the testing activities. Then recently, we have developed a virtual platform, a consultancy platform that is intended for consultancy services. So then the users can send us their consultation requests for us to address them and give them the best solution.
Communication systems have become a key element in today's world where virtual events and virtual meetings take place worldwide. High-speed digital systems, microwaves, and optics systems merge together to meet the requirements of a growing demand for high-capacity links. Alter Technology combines its expertise areas to meet the requirements of future communication systems.
So space continues being in the trend, and Alter is just there.
As a leading space technology and intelligence company, Maxar helps customers unlock the promise of space to solve problems on Earth and beyond. Whether it's collecting geospatial data to help organizations build reliable maps for their consumers, providing the intelligence governments need for national security and sound decision-making, or building spacecraft components that will send the next astronauts to the moon and beyond. Our capabilities in space infrastructure and Earth intelligence turn big ideas into successful missions.
Time and time again, people have been gazing up at the night sky, looking for understanding and answers. But what if the answers might actually lie in the constellations staring back at us? Hundreds of kilometers away, small satellite constellations observe the whole wide world. Despite the distance, these satellites can be harnessed to satisfy our need for instant, reliable information and to benefit everyday life on Earth. Everything from national security to nature monitoring can be improved with space technology. We can now use remote sensing for blue-green algae monitoring in near real time, or rely on satellites to provide fast and robust communications during national security emergencies. At VTT, we believe space technology to be the answer to many of the pressing issues we face today. That's why for decades now, we've been working in space innovation together with our key partners, such as the European Space Agency. We have created the world's first hyperspectral cameras for small satellites and the first W-band millimeter wave radios operating in space. For us, it's not just about exploring what's out there. Our bold vision is to make space technology an integral part of the day-to-day life on Earth, with technologies like beyond 5G, hyperspectral imaging, and Earth observation. Want to join us in making a difference on Earth and beyond?
We
Harp Technologies is a Finnish SME company providing technology and R&D services in the area of RF and microwave engineering. Our customers are system integrators, equipment suppliers, research institutes, the European Space Agency and defense forces. We help our customers to develop innovative and competitive products, and we develop methods and technology to acquire critical measurement data. Our customers operate in the domains of space, defense and security, remote sensing, and IoT and telecom. Our activities are organized into 4 business lines: microwave sensors, microwave components, signal processing, and electromagnetics. In what follows, we present some sample equipment that we have developed for our customers. Within our microwave sensor business line, we develop radars and passive sensors and their subsystems for space, defense, and remote sensing. As an example, here is a passive sensor, a microwave radiometer. Radiometers are useful for various remote sensing applications. Within our microwave components business line, we design and develop components according to customer specifications. Here is one example, a low-loss ferrite switch. On the right, you can see how the switch works. The signal is first directed into one port, and after switching, into the other port. Within our signal processing business lines, we develop algorithms and technology to improve the performance of microwave sensors. As an example, here is a signal processor to detect and filter out radio frequency interference. The antenna is the key component in many radio frequency systems. Within our electromagnetics business line, we develop antennas for various applications. Here is one example, an antenna for the radar altimeter of a planetary lander. Harp Technologies provides technology and R&D services in RF and microwave engineering within 4 business lines. We support our customers in various application domains.
So, hello everybody. Are you already back from the sessions? At least some of you, I presume.
Onboard imaging have resumed.
Excellent. And I see other sessions start to end as well. So next in our program is Industry Hour, and let's take a quick look to the program again. So what we have now is a short break between the sessions. We still probably get company from other sessions as well. So space's situational awareness session is still ongoing. Onboard imaging has few people in, and the Earth observation session starts to be empty as well. So that means we can proceed with the program. After these sessions at 1 o'clock sharp, Markus will take over and will have interviews with different representatives of companies, and we also have breakout rooms for different companies, so you can have face-to-face through the video discussion with industry representatives, ask what they are doing, ask for offers, ask for more information about their products. And after industry hour, we have again a plenary session. And today we have a plenary session talks from ICEYE, who is going to tell what new generation ICEYE radars are able to do, what kind of new types of data we're going to get, and how many satellites ICEYE has been launched and going to launch. And then we have also a very interesting presentation about the results of study, what kind of investment needs Finland would need to get small satellite support for the Finnish ground segment. So this is also definitely a very interesting topic for the whole small satellite community. And then after that, we're going to have sessions again. We have a biodiversity and climate session. The onboard imaging session will continue, and we have also a payloads session which covers different payload developments in Finland and also internationally. And the last session of the day is going to be interactive session like it was yesterday. During the interactive session, we have a breakout room for every single presentation for 20 minutes, and the author can present however he or she finds it more comfortable to present the work, and for 20 minutes you can interact with the author there online. And we try to close the event around 5:10, 5:20 and close the entire event. We have already uploaded also many slides of today, so you can go to the web page of the conference and find additional material, and also you can add additional material to this page by accessing your abstract submission form. If you submit from the abstract submission form a file, this file will be linked with a schedule and will appear on the web page. But Markus, are you already online?
Yes.
Excellent. And can you give a couple of words about what kind of companies we're going to have in the industry hour today?
Yes, we'll have CGI, which is a software company, and DA Group, which is a Finnish space-related engineering company. Also Bitcomp, Harp Technologies, Reorbit, Hult, DHV Technology, Yxloon, Isavare, Airbus, and Icy Space, and then PASQ Space. That one is a new addition, and I have to ask them how I should pronounce that name even.
Yeah, that's I don't know as well, but I know they are from Kiruna. It seems like the link to northern Sweden, and Kiruna is a very strong here this year, and we have a lot of representatives and missions and services from Kiruna. And Kiruna is taking long leaps forward to become the first orbital launch, or the launch place where we actually can go to the orbit with small satellites. And I really wish this will develop fast, and we're going to have in Scandinavia a real launch site where we can access orbital heights and go to the orbit with our satellite. So Kvarkensat might be one of the first small satellites which is going to be launched to orbit from Kiruna, if we are lucky. But of course, there are many developments before we will reach this status. All right, so I recommend that everybody who are intending to take a lunch during this hour will keep the not mics, but at least the speakers open, so you can listen what is happening in the industrial space technology world, and where we can get our new platforms and payloads in order to study both Earth and space by means of Earth observation and space science, or go to the next asteroid with the newest and the best platforms and these instruments. So I would gladly give the mic now over to Markus. So do you have already your first participants online or not yet?
It seems that Tuukka and Sakari aren't yet present here. Or now Sakari just appeared.
Okay, so that's good. We are of course
Hello.
a bit early as well. Hello, Sakari.
Hello.
So I'm already trying to start to give the session over to Markus, who is the host of the Industry Hour. So how are you doing?
I'm doing fine. Just came from lunch and it's a nice day outside.
Excellent. Yeah, we still have technically sort of summer in Finland, although latest days have been a bit cold or at the chilly side, at least for summer, after this hot summer at least.
Yeah, keeping the fingers crossed for at least some nice summer cabin weather for the weekends.
Yes. How was yesterday, by the way, the Industry Hour? Did you get also people to your breakout room to discuss the products and selection what you are providing?
Well, to be honest, it was a bit challenging because, of course, there was overlap with the general Industry Hour and the presentations here, but we did get some audience and some discussion going on with them. So a bit challenging, but not completely.
Yeah, we try to develop the concept as well. So, but we try to give a fair amount of time to also to industry. And if industry has a very interesting presentations from the science perspective, we are also booking them into the program. But mainly a sort of commercial interaction is now limited during the Industry Hour. And of course, everybody can also ask questions like during the conference, but of course then you have to know the names of people. So I recommend everybody take a note. If you are interested in some of the products, you can find these people online, perhaps also after Industry Hour. But thank you very much from my side, and Markus, you will take now over the Industry Hour, and I will mute myself and put the big logo screen on the background so you could go forward with the Industry Hour. So have a nice time here.
Yes, thank you. First of all, Marius, are you online? Maybe you can handle the putting people on the stage. Just taking it.
Yes, should be working, I guess, right now.
Okay. I will make you host for that time.
Ooh.
Okay. Like so. Now you should have the capability to arrange the people to the stage. Is it working for you?
Can you see that? So actually it should work right now.
Yeah.
Okay.
Okay.
Perfect.
Yeah. So the first company would be CGI. And from there we have Tuukka Mattila and Sakari Sarjakoski in my timetable at least. And I seem to see that both of you are present here. Can you hear me?
Yes, I hear you. What about Tuukka? Are you here already?
Yes, I am. Just a moment.
Hello.
Hello.
Let me fix the lighting a bit.
Okay, now you're visible completely.
Good.
So CGI, I believe CGI is a Canadian software company, or IT company? Am I right?
Yes, you're right, but we here are especially representing CGI Finland, which is almost like, well, officially, of course, a company of its own as well.
Okay.
It's a big company, of course, so
okay.
We wouldn't be able to tell everything that CGI does on the space frontier, and there's a lot.
Okay, so CGI is present in space, or at least you have space activities.
Yeah, and I think Tuukka will have something kättä pidempää to give some more details on that.
He's armed with the presentation.
Yes. Sorry
for
that.
Can you see my screen?
Yes.
Okay, yeah. So hello, I'm Tuukka Mattila, Technical Project Manager at CGI Finland, the Location Services Unit. And here's also Sakari Sarjakoski, the one who was speaking. And he's working as a consultant in our project. So I'm just giving a brief overview what we are talking about here. So we have 3 topics. So I'm going to speak a little bit about CGI, and then Sakari is going to present CGI's remote sensing project, and then just a couple of words about the recruitment opportunities at CGI. So I think you asked what CGI does in space. So basically, we started the space and GIS experience from 1970s, and from decades we have been partner for many clients worldwide. So basically, we're working in every field which relates to space technology, and of course we are a big company, so over 70,000 people around the world. And then in Finland, we have 3,700 people. And in our location services unit, we are only 60 persons approximately. So we are more like a small company inside a big IT house.
But Tuukka, I would like to mention that at least we are saying that we're the biggest concentration of GIS professionals in Finland. So I think that's worth a mention here in this context.
Yeah, that's true. Yeah. And so in Finland, we have been working with the Finnish Food Authority, the FMI, Meteorological Institute, and the National Land Survey of Finland. And one of the projects what we have related to the CGI space is actually the one that Sakari will be presenting here. So maybe Sakari, you can tell a couple of words about this. You're muted, so.
Sorry about that, I didn't notice. Yeah, so I think this is one of the most interesting projects we're working on at the moment, at least those that are public, and it's got to do with agricultural monitoring of or via Earth observation. So we're in this project, we are the end users of the data that are produced and generated by the satellites that we are discussing here as well. The main idea is to monitor the agricultural subsidy applications that are declared by the farmers, and to see whether the farmers are actually doing things that comply with the subsidy applications. That is, they are sowing the correct crop type, and they are mowing, if they plant grasslands, that they mow them at least once a year, and so on. And those are things that we can detect from space, of course. And we are utilizing Sentinel data mainly, Sentinel-1 radar data and Sentinel-2. And especially Sentinel-1 is important for us in Finland because there's a lot of cloud cover, and lots of parcels would be completely blocked from the satellite view, from optical satellite view, if we didn't have that kind of cloud penetrating radar data. Yeah, and those data are extracted to each parcel, so we get some statistical numbers from each acquisition, and those are then compiled into time series, and the time series is analyzed to to classify the crop type or detect and classify it, and then also to detect changes in the phenology or the land cover, mainly mowing or other agricultural activities that are like sudden changes.
So if I interrupt you, plant types can be you can tell apart different plant types from cloud penetrating radar imagery.
Yeah, to be honest, the optical data is more reliable, but we can get good enough results, at least from our opinion, also based on the Sentinel-1 data. And one useful part is that even if there's gaps in the optical data, the Sentinel-1 data will then fill those gaps, and we're left with at least some data that the AI can then ingest and make classifications. But especially the crop classification is a bit difficult based on Sentinel-1 data alone, but changes like mowing and such things are also
that seems like easier task to do.
Yeah, of course it's Sentinel-1 data is noisier than the optical data, but that's something that we can also like get an idea from those observations. So yeah, it's interesting, and of course the results are not perfect, and that's one thing that we are currently working on is to improve our results and actually compare the results with some ground data, so that we actually know how accurate it is in reality.
Okay.
Yeah.
Fine.
I think I'm out of time. I would like to go on, but if we are
I might ask still, does CGI have some like recruitment opportunities? Or do you need people, or are you fully staffed?
No, definitely we are not fully staffed, and for example in this project we do need more hands on the deck, and we need IT personnel and like software developers, but also people with good understanding on remote sensing, especially like combination of remote sensing and land cover phenology and those things. And the really rare unicorns that we would want to catch are those who know something about all of it, but that's highly unrealistic. But we are trying to find those as well. Yeah. Tuukka, do you want to add something on that?
Yeah, so basically you can take your QR code reader and check the web page, which is behind the QR code. But here are the tag words. So basically we're looking for DevOps, software development, data science, and remote sensing specialists. So you can check more. But yeah, in the end, I would say that you can join our breakout room. So there will be more detailed presentation about the project. Sakari is going to show the poster. It would have been a physical one, but okay, this is online event. So and then we're going to have open discussion, questions, etc. And then our director Hannu, who's on the line, he's also coming there to have an open discussion. So that's it.
Fine. Then thank you for participating, and the next company would then be DA Group, and from there Nestori Fabritius.
Thank you.
According to my table, is Nestori present here?
Yes, I'm here. So I'm happy to hear you.
Okay, fine. So DA Group, who are you and what do you do?
So we are a company that is doing advanced solutions from seabed to space. So our roots are in engineering company, but currently we are doing also different type of products that are used in seabed or in commercial applications in Earth or in space. So this is in nutshell our company, and our core is basically the engineering know-how. And in this our core competencies are in embedded systems, and there is FPGA design, electrical design, signal processing, and also embedded software and radio frequency things that we have been doing since 70s.
Okay. I should ask that what's the situation of Finnish National Space Situational Radar? Like, you are involved with that, I'm under the impression.
Earlier today, I already gave a speech about the SST radar, but the current situation in Finland is that what is basically lacking is the budget for the radar. There is a strong know-how building being evolved in the recent years. This has been also in our company, but also in Sodankylä Observatory and also in Air Forces. So there are many entities that are building the technological background for this radar, but the lacking is that there is no funding currently available. And this is something that I hope that the future years will bring.
So this is like space situational radar means tracking small orbital bodies or orbiting entities.
That's correct, and the aim is to have it in that sense that we can identify centimeter scale objects that are the threats, that there could be really bad collisions, and this helps also the small satellite operators to in advance to take the mission approach where they think that they can be using their satellites, and when it's time to avoid the collision or the dangerous zones, it can be taken in advance in the mission planning.
Okay, and it's obvious that if that kind of capability is advanced enough, it would have defense like applications too.
Yeah, of course, the EU is already now really interested in the defense applications, and this means also that there are different type of studies how to actually use the data that can be gathered from the different radars.
Okay.
So it's dual use.
Okay. So if there is a national project, what would be its impact?
Yeah, I think the major impact is that the technological know-how build-up is the one point, but also it generates for the companies export possibilities, because we are not, of course, not the only nationality that is planning for such devices. So this would be really great opportunity to the industry to have the possibility to export this knowledge.
Obviously. So that all makes sense. So your role as DA group in this kind of project would be what?
Yeah, our hope is that the governmental entity like Sodankylä would take the responsibility to operate the radar, but our goal is of course that we could be the industrial partner who actually builds the radar and provides the upkeep services for that.
Okay. That's certainly a very interesting topic. Will you have a breakout room here?
Yeah, we have a breakout room, so please come to visit us and we can talk about more.
If this is an interesting topic for viewers, then this is certainly a room that should be checked out. Thank you. Thank you for participating here.
Thank you.
And next would be Bitcomp and Tapani Stienval, according to my table. You are muted.
Okay, can you hear me now?
Yes.
And can you see the video?
Yes.
Very good.
Okay, so Bitcomp, you are involved in space operations, am I right?
That's correct.
Okay.
We work in field of bioeconomy, mainly forestry, but we utilize space quite a bit.
Okay. So you are using satellites in daily operations, and can you tell us about what you do with them?
So currently in operational use, we are using satellite data from ESA to detect any loggings, legal or illegal, as well as storm damages in the forests. And this service is used by the Finnish Forest Center, and we are the company operating this service. So we use satellite images, and then we use artificial intelligence to detect the changes in the environment.
Okay, that's interesting. So this might involve some machine learning also to detect those changes, because the data amounts, the quantity is vast.
Yes, it's quite vast, and indeed we are using machine learning. We also use scripts to automatically detect whenever we have an updated image without too much cloud content blocking the observation.
Okay, so the next goals, or what are the next moves in space industry that your company will have?
Well, currently we are actually using, we are working with the European Space Agency in collaboration to create the next stage of how we can use this satellite imaging and machine learning or artificial intelligence to use it for so-called vitality mapping of the forests. And we are, as we speak, launching a service in Germany where we can detect the forest vitality and therefore predict the risks of insect damages in the forests. And these are an enormous problem in Central Europe currently. Vast amounts of forests are being destroyed by bark beetle and other insects. So we are developing a way to mitigate the risk and try to prevent at least part of the damages.
Okay. So for you two, I would address the question, are you fully staffed or are you recruiting?
We are recruiting all the time. So last year, the company headcount increased by 38%, if I remember correctly.
38%. That's like percentage-wise. That's
percentage-wise. Of course, we are still a not too big company, but we do employ almost 70 people already in Finland. So we're talking about tens of positions that will look people in all kinds of fields from GIS, artificial intelligence, and AWS or cloud services coding, basically.
Okay, that's a very interesting set of like capabilities you have there and services. Okay, nice and concise. Will you have a breakout room here?
Yes, I believe that we do have a breakout room, and so if you have any questions or comments or are interested in our solutions, then feel free to drop by.
Yes, I believe people will. Thank you for participating. Next one would be Harp Technologies and Petri Jukkala.
Hello.
Hello.
Here I am.
Okay, so audio and video are go, and so Harp Technology is a new name for at least some of us. What are you and what do you do?
Yeah, we are not a new company, even though everyone is not familiar to us. The company was starting at 2007, and the company is specializing on radio frequency technology. And what we do are we provide technology and R&D services to the customers at a frequency range of from megahertz to about 100 gigahertz area.
Okay, so you're a radio equipment centered company.
Yep.
Okay,
but not only radio frequency, we provide components, subsystems, and systems operating at radio frequency but we also make RF signal processing, and that includes also radio frequency interference related processing, meaning detection, classification, mitigation.
Okay, so what kind of customers do you have for these applications?
We have quite a wide range of customers. Quite natural customers are military forces and ESA and other research organizations. But we also have quite a number of industrial companies, starting from startups and going up to large-scale integrators and international corporations.
Okay, so can you mention some projects, or are they? I understand that due to the defense related issues, many of them might be like you can't mention them.
Yeah, naturally, defense and industry projects are something under NDAs. But one quite a good example of what we are doing is an ESA project where we make the dual redundant low noise amplifier for the telecommunication satellites. And this operates at the W band around 80 gigahertz, and it has a 2-channel redundant for the redundancy, so it is called redundant. And it uses our low loss ferrite technology switches, and then French ohmic low noise MMICs.
Okay. I should also ask from you that are you like completely staffed, or do you have like recruitment opportunities?
Well, we have been growing quite steadily past couple of years. I joined the company 3 years ago, and the headcount has doubled since then. And we are all the time recruiting. At the moment, we have one open position for the RF design engineer. So, and of course, also other applications are always welcome as an open applications, because we can see and tune the work according to the applicants.
Obviously, as is pretty usual.
And actually, this recruiting people has been one limiting factor of the company growth. As is the same is for many other companies, I'm sure about.
I think this is common for many companies nowadays. So will you have a breakout room here?
Yes, we do.
Okay, that's interesting. Your set of technologies is rather interesting, and not many companies with this set of technologies here. I certainly will at least look at the recording or come and see what you have there. But thank you for having time to participate here.
Okay, thank you.
Next, after HARP would be Reorbit, and let's see if I can get this right. Sethu Sevada Suvenam.
Yes. Hey, Marcus.
Hi. So Reorbit. I believe you were here yesterday, but there are new people around here today. So Reorbit, what do you do?
So Reorbit is a new startup within the Finnish ecosystem. So we are 1.5-year-old venture-backed company. So what we do, I'll probably give a bit of background before we say what we do. So today, if you look at how satellite and space systems are built, they're still following the legacy of Apollo program, meaning that you tend to push quite a lot of functionality into one big metallic piece of box, which is the satellite, and then just launch and keep your fingers crossed that everything would magically work in space smoothly, mostly, which is not the case. So what we do at Reorbit is really trying to break away from this trend of form following the functionality. So in a way, at Reorbit, we are building systems that are much more distributed in space, so that instead of you focusing on pushing all the functionality into one piece of satellite, we are enabling companies to open up and build satellite systems where you could start distributing your functionalities and fly these in a distributed manner in space, which are connected, which are fully autonomous.
So like you would have a separate propulsion system or separate communication system that are like flying separately?
Yes, exactly. That's the idea or the vision that we are planning to go. So let's say today, if you have like any platforms that's operating, and say a couple of years down the line, either your payload is like advanced, or let's say there's been a small malfunction on one part of your subsystems of your platform. So you're just throwing it away or abandoning this platform. Whereas with our thesis is that when you start getting away from the form or single form and start distributing your systems in a multiple units where they could fight close to each other and start communicating with each other. So if you want to upgrade your payload, say a couple of years down the line, or if there's a fault in one of your subsystems, instead of just throwing away your whole almost fully functional platform, you could just replace your units as and when you need to do that. But that's a grand vision. But what we are currently working on is actually we are working on a platform which we call it as Gluon, which is designed for it's a microsatellite platform, and it's quite flexible platform since we are following what we call it as a software-defined architecture. So that will enable us to really scale up from all the way from 100 to 500 kilograms with minimal non-recurring engineering. And this platform comes in with a built-in capability to be highly autonomous, meaning we are optimizing on the station keeping and fault-tolerant FTIR. Also, the platform is designed for beyond LEO environments to operate in MEO and small GEO. So this is the reliability is on the corner or like in the center of what we are building with this platform.
Okay. So this means that a single platform would have to be autonomous and reconfigurable.
Exactly. So we are, yeah, exactly. So today, as I said, we are entering the market with our platform, and this platform would come in with certain advanced features, but then it's up to the customers to open up those features or not. But the platform will be capable of it will be highly autonomous when it comes to the station keeping and the FTIR. So we call this internally fly and forget. So once you launch it, and let's say you have a constellation, so you launch your first satellite, you launch your second satellite, then these are straight away talking with each other, and then you could just say, like, if you want these things to be 120-degree apart, with a click of enter, so you could sort of keep these 120-degree apart. So in a way, we are really taking the babysitting away from the platform, which is today costing quite a lot for the operators.
And that is certainly true that the sort of babysitting takes a lot of time, but that, yeah. So your project certainly requires a lot from the station keeping side, but it solves other problems nicely.
Yeah. Yes, it's as I said, our grand vision is to really move there, but again, we are entering the market with not so radical thought processes, but in a way, I think still making platforms autonomous is in itself quite an advanced feature that we are adding in. And given that it's again the way we are building our platforms are really like software defined, so that will enable us to really build high reliable platforms with really low cost with these advanced features.
Okay, that's a quite interesting set of ideas. Interesting to see what that will be in 2 or 3 years.
Because similar to what computers have gone through with the internet revolution. It's very amazing that space or satellites being very advanced, still satellites can't talk with each other, can't be connected with each other like our computers does. So people, given that the number of satellites are exponentially increasing day to day with launches, so sooner than later people will start realizing that satellites have to go through this internet revolution, and that's something what we are building. The core of what we are actually aiming is that. So at certain point, someone will have to tackle this. Satellites cannot be satellites cannot be loners in space, so they have to talk, they have to be autonomous. So we see that sometime industry will move towards that, and we are really taking the first steps towards that as a company.
Interesting.
So if people are interested, we have a breakout room, and we'll be happy to discuss a bit more on what we are doing.
Okay, thanks for having time to come here.
Yeah, thank you.
Yeah. Next one would be Hult and Lassi Sutela.
Yes,
Hult,
hello.
So Hult being the fusion of the older Hult and SSF.
Yes, or actually
yes.
RDVelho and SSF. That's currently Hult.
Yeah. So you were present yesterday, but today you are with a new topic, drones and visual navigation.
That's true. That's true.
Okay.
So a few words about visual navigation. What does it mean in drones? So basically, when we are talking about navigation in drones, we may have two possible scenarios there. First of all, we may want to do it without GNSS, so without GPS signal. For some reason, for example, GPS signal doesn't exist, or we want to have some kind of second source of location data. And another scenario is that when we are doing, for example, parcel delivery, it's quite important to know that where we are able to land, and we need to be able to detect the objects, for example, in parking area. And we are solving those problems here.
So visual navigation would be like if for some reason GPS doesn't work. I think in defense sector there are reasons
for
to
example.
want this. then we don't need exceedingly accurate like inertial navigation, or we can actually make do without it.
Yeah, that's true.
Based on visual cues. That seems like an AI problem.
That's an AI problem. So basically what we are doing, we are having a camera which is taking video feed from ground, and in real time we are mapping that visual data on top of map layer and comparing those, and that way we can get the exact location of the drone.
Okay, so it's like a visual version of Tercom.
That's true.
Okay, if like terrain and contour mapping, but we are talking about visual cues in the the area that is below the drone.
Yeah, it's below the drone.
Okay.
Of course, we can tilt the angle if we want to do that, but in most cases, it's directly below the drone.
Yeah. Okay. So what kind of applications do you have in mind for this?
Well, of course, you already mentioned the military applications. That's one area. But another area is that, for example, from risk management point of view, in some cases, we want to have a separate system which is not dependent on GPS signal. That's clearly one case. And as I already mentioned, one obvious scenario is parcel delivery. So if you want to land the drone, for example, on parking area, it's extremely important to understand that there is an empty lot where the drone can land, and it can be done with this system.
Okay. So could I, for example, think of parcel delivery so that I order something and then I print an A4 sheet with a QR code, set it to my yard, and then the drone flies over and detects this QR code and lands there?
Well, that's one approach, but we'd be considering more the approach that we, for example, give the area that yard is here, and then the drone finds the empty area from that specified area and then lands there. So we don't need any infrastructure on ground to do it.
Okay. Yeah, that sounds like a very interesting topic. What brought Hult to consider these kinds of ideas?
Well, the idea was first to make a geolocation of small satellite images, and it's still fully possible. But then we found out that actually drone area is probably more interesting for this technology, and that's why we transferred from space to unmanned aviation.
Okay.
That was our path.
Okay, thank you. This is a rather interesting idea.
Yeah.
Do you have a breakout room? Yeah.
Unfortunately, we don't have breakout room, but Rizwan Asif is going to have another presentation later on today.
Who?
Rizwan Asif.
Okay, thank you. So thanks for having the time to explain this thing.
Thank you.
Okay, the next company would be DHV Technology and Victor Burgos, if he is present. And I can see Victor there, but he's still muted. let's give him some time. Well, it seems like Victor is not with us currently. We can maybe take him after the next one. So then it would be Yaxloon International and Miguel Angel Ruiz Souza.
Hello.
Hello. You can hear me? Okay,
yes,
thank
I
you.
can hear you.
Okay.
Okay, you can hear me and you can see me.
Yes. So you were present yesterday also, but as I said, we have new people here today. So you are a company that does X-ray things, right?
Exactly.
Okay.
And today I had my presentation. So as you can see, basically what you can see in the presentation from today is that we can see defects, the effect of defects in many different parts. Can be additive manufacturing, can be electrical boards, can be actuators. But I would say that's a little bit the beginning of the history.
Okay.
So we are approaching.
Okay.
The idea is, of course, try to, let me say, CT is the technology who is able to create an amazing amount of information. And to select what information is the proper one for every case, it's not easy. And the idea is to avoid that the defects appear thanks the use of artificial intelligence and so on.
Yeah. So what kind of things can be discovered with CT imaging that cannot be, let's say, with ultrasonic techniques?
For example, ultrasonics, you always need to get back the signal. So you need to have some kind of parallel surface with X-rays and computer tomography. You just don't touch the sample. You go through the sample with the X-rays, and then you are able to analyze. You are able, in function of the different gain values, to see different materials, if there are delaminations, cracks. And with help of the software, you can see what happens if I put my CT model in a stress software to see what is going to happen, how it's going to evolutionate these potential defects, for example.
Okay. So what are your businesses in Scandinavia currently?
In Scandinavia, let me say, it's a white spot. That
Okay.
is one of my questions will be if there is someone in the audience who say, oh, that could be interesting for me to take care of your products in Scandinavia. That could be really interesting for us. Because right now we were looking aerospace more like the aero. So big bodies, engines, the typical aviation business. And now we are discovering, probably like many of the people here, what is going on in all this new space. It was for me amazing to see how many control of our normal lives is running through small satellites. Yep. It's really very, very interesting.
Okay, nice. I believe like even a small space also has requirements for these kinds of imaging services, because
yes, I think so.
Even small space satellites are rather expensive to launch, so they can't be like, let's see if it works. And then...
Yes, I can imagine that right now you can see in the business there is a lot of startups, small companies, universities, but I suppose that in some moment this is going to be some kind of concentration, and most probably nowadays our customers will be more maybe the service providers of the small satellite companies, but I believe that is going to grow quickly in the next years. Okay. At least all expectations say this business is growing very quickly.
Okay, fine. Will you have a breakout room here?
Yeah.
Okay, nice. So I think people can find interesting information about you and your doings.
Yes, for us it's important just to see what is going on. It really makes sense for us to put more dedication in this business. And my impression is quite positive, definitive.
Fine. Yeah. Again, thanks for having time for us.
Okay, thank you to you.
Thank you. The next company would be Isavare, and David Leal Martinez.
That's right. Hello.
Hello.
So, well, it seems that you can hear me quite nicely.
And see. So, Isavare, who are you and what's your goal?
Well, we are, as our name is, it's heading towards, we're a company that wants to be aware. We want to provide situational awareness for the surroundings, whatever your surroundings may be. It may be here on the ground or on the air or even on space. And basically, our first company goal, the one we're after today, is to become a leading company or a leading player in the world regarding space situational awareness. We want to provide space weather services and as well as data. I can share if I can find the share screen. If I'm available to share, I could tell you a tiny bit more details if this thing cooperates a bit with me. So
I have more to ask of you. Okay. Now it seems to work.
It seems to work. Okay. So basically you might ask me, well, David, why space weather? What's special about it? And well, it's as you can see in my background, it can bring very nice visual effects to your evening if you're in Lapland. But it also brings together some problems. Like, for example, you're right now with Lassi from Hult, we're discussing, well, what if GPS breaks down? And well, space weather can do that, can really affect the global positioning systems and bring some other tons of problems that are fixed in the background. So what we want to provide here is the means for the providers and for the people behind the curtains to know when disruptions will come. And then as we go forward in time, to be able to predict serious space weather events that will bring trouble.
Okay.
I've got some experience already from previous missions in space, which has led us to develop now technology. We have right now our latest development is called XFMCS, that it's a X-ray flux monitor that basically we're talking about hardware, but we're also into artificial intelligence and making services based on AI, so that to use that data and give services.
Okay. So there's a project called Sunstorm, which I believe was launched last Monday.
That's right. Last Monday, we have been working right now. You could say that Sunstorm has been our first launch as a company. And we were in this project together with Reactor Space Lab. And basically, they provide the satellite body and we provide the instrument. So a demonstration of our XFM instrument that now is called Sunstorm 1. And right now, well, it's the let's say the leading instrument regarding X-ray flux monitor. So right now we're quite confident that that our product is one of a kind. So that is the case. So right now we're preparing these two missions to go into the Lagrange points, both with NASA and ESA, that they have both decided to take our instrument to their missions to be monitoring the sun.
So Earth-Sun Lagrange points.
Yes.
Yes. Okay. Because there's also the Earth-Moon system, but regarding you, it's clearly the Earth-Sun system Lagrange points. Okay. With these kinds of sensors, what kind of times would it be like you could predict space weather, these kinds of X-ray events?
Well, basically, right now, what we are, let's say, starting our approach towards this space situational awareness. Right now, our instrument, what it can do is it can give us greater resolution. Right now, it complements very nicely with right now, most of the measurements are provided by SOHO. And in this case, our instrument, I mean, we have been working together with NASA on how to use Sunstorm data to work together with SOHO data and start taking our steps towards providing these services. And well, I could say that today our hardware division or our instruments are ready and flying. Now our next ones that go to Lagrange points will be radiation tolerant. We'll have even greater resolution. But regarding services, we have been working closely with Finnish Meteorological Institute, with Vaisala, and doing situational awareness projects here on Earth. For example, we have now this micro weather service for airport systems, which we are piloting now in Helsinki-Vantaa Airport, that can give greater time and spatial resolution to be able to go around and navigate successfully around complicated weather systems. So we are also now working on starting to take all of these lessons learned into space weather now that we get our instrument and start getting the new data.
Okay, thank you. It's a very interesting service you have there. I believe you are the only one in Finland with this kind of services. But
that's right. It's something that we're proud that we've been pushing for a long time from the founding of the company, and right now we see it take wing, and we have big plans to put that it all comes together, because we are somehow trying to make this ecosystem work in a way that we have ground systems or things that help you here on Earth, give you awareness on the ground, that will be able to give us funds to continue our space endeavors, that will then produce new technologies that we can spin off again for the ground, and hopefully have this infinite loop of knowledge and money that will get us to rule the world at some point.
Yeah, that's a good goal. Well, will you have a breakout room here?
Unfortunately, we will not be having a breakout room, because we are in quite a tight spot, as we are. Well, these two missions that I showcased, well, they need tons of paperwork, and right now we're very close to a deadline. So we will be around and hopefully be more active and to be available.
So you have company things to do.
Yeah, okay. Unfortunately, the things won't fly themselves yet.
Yeah.
So we're hoping to do that in time. But
okay.
I wanted just to talk a bit now that you asked about a breakout room and some more info. Right now, our next steps in space involve now, we were looking now as Sunstorm has taken wing. We're planning to have the satellite constellation of similar versions of XFM, so that we are able to put together the data that will be acquired from the Lagrange points and see how it really affects our Earth's ionosphere by having real-time data from 76 points around the world, and that will we expect to give us a leading edge and a means to really confirm and take forward the existing space weather models, and that way be able to really take a foothold in space weather services.
Okay.
Maybe I spoke too much by now.
Yeah, but thank you for informing us about this, and thanks for having time for us, even though you have a lot to do in your company.
It's a pleasure always to come here. So thanks for the time, also for the visibility. It's always nice to try to more people.
Many people will remember this, because this isn't like there aren't many companies with these kinds of things going on. Okay.
Excellent. Well, thank you, Markus, and have a good day.
Thank you. I believe the Victor Burgos from DHV Technology is now present with us.
Yeah, hello. Can you hear me?
Yes. Hi. So DHV Technology, who are you?
Okay, so we are a company which we are based in Spain, okay, in Europe. So we are developing starting from the design until the delivery to the customer, solar panels for space applications. Okay, so we are in the phase of the design, manufacturing, and testing phase of customized solar panels and electronic and electric power subsystems for the satellites.
Okay. How young or new company are you?
So we are a young company. Okay, we are part of the new space companies that we have now in the space industry. We start in 2013. Okay, so right now we are in the 7th year this year. So from the beginning we started as a very small company, but right now we are almost 70 people working on it. Okay, part of the team is working in the engineering team, because as I said, we are working also on the design of the customized design of the subsystems, but also part of the team are part of the manufacturing phase, testing phase, and quality assurance.
Okay, 70 people in that's
It's a company already.
Yes. All of us we are based in Spain in the same facilities. Okay, but we are also working with companies from all around the world.
Okay. What kind of projects have you been involved with? Can you specify anything?
Okay. Yeah, so we start with CubeSat projects. Okay, we start with standard solar panels designed, and then we pass through the deployable solar panels for CubeSats. We start also with body-mounted panels, fixed panels of small sats, but right now we are also even working with deployable small sat solar panels. Okay, we are working with systems which are reaching more than 2 kilowatts, okay, per satellite, which is a big number in terms of small sats designs.
How many kilowatts?
And all these designs that we have been working in it. We are working in orbits like LEO orbit, MEO orbit, but also GTO orbit as a non-standard orbit that we are working with.
Okay. What were the power levels you specified? Just.
Yeah. So depending, as I said, we are working with customized designs. So that means that we receive some requirements from the customers. Okay. So we evaluate these requirements for the mission. We evaluate the type of mission that we need to work with, and then finally we create a solar panel which fits on this mission. So, for example, in CubeSats, we have been working up to 200 watts, for example, with a big deployable panel. But also in terms of small sat, as I said before, we have reached up to 2 kilowatts. Okay. 2,000 watts. Yeah.
That's requires some engineering knowledge to know how to do that in space.
Yes, one of the big challenges that we normally have is to include the most of the power in the less of the volume mass. Okay, so this is the big challenge that we have nowadays. As you may know, so each kilogram that we add to a satellite, it could be an issue for the satellite company. So we try to minimize the mass, to minimize the volume, and that means to have a complex system with a complex deployable system. Okay, so that is one of the most complex things that today we have. So to minimize the volume and mass, increasing the power.
Okay. Thank you for having time to be here with us.
Okay, thank you to all of you. And if you have some questions, okay, now I will put my mail and webpage here in the chat. And if you have some other questions, please go ahead. Okay. Thank you very much.
Thank you.
Bye.
Bye. Next in my timetable would be Airbus and Diego Yannick. Or is it Yannick Diego? Which
Yannick Diego. Yannick Diego.
Okay.
In French, because I'm a French guy located in Germany, Bremen. Hello, Marcos.
Hello. Nice to have you for a second time here. Now, I believe you are involved in a project called Bartolomeo.
You're right.
Yes. So, what is that?
Yeah, Bartolomeo is a external platform located since 1 year on the ISS, so attached directly on the Columbus module. And the mission of the Bartolomeo is to host payloads, whatever the payload is, whatever the shape, to allow different kind of mission, like in-orbit demonstration of observation, deep space observation, and so on and so on. So we have no limitation. So it's a very versatile product because we can host small payload from one use, so focusing on the new space and startups and this new space business, and up to quite much larger payload, because we can reach 450 kilogram and more than 1 cubic meter.
Can you say again, more than 1 cubic meter?
Yeah, the maximum is 1.3, I think, cubic meters. So it's something more than 1 meter long, nearly 1 meter large, and 1 meter high. So
okay,
it's quite big.
Okay, what's the story behind this project?
Yeah, so the story behind this is that it started, I think, more or less 7 years ago, because at the time NASA, and it's still the case, but at the time NASA was thinking about increasing the capacity of the ISS for hosting payloads, and in parallel as well developing what we call the space commercialization and the ISS commercialization. And so they were looking for capacity to host additional payload outside the ISS, following the development of the Japanese external module. And so we have proposed them Bartolomeo. So surely at the time it was not Bartolomeo's name, but we proposed them this kind of system. And as we were more European than the US, we moved to ESA, and we closed a PPT, so a private partnership with ESA, to make happen this Bartolomeo. For your information, Bartolomeo is a fully fully product and services developed and financed fund by Airbus. And maybe you will be maybe surprised, but it's not so often that Airbus Defence and Space, or space system, take over the full funding of such a product.
Okay. So what's the role of ESA in this?
ESA is our partner. So we have, as I said, a private-public partner, and ESA, of course, allow us to use the ISS, to attach Bartolomeo to the ISS, and to use the capacity of the ISS, mainly their power and data download and upload. So it means we are using the MPCC, so the communication system of the ISS, and of course the ground station of the Columbus module, the ground stations, and it's mainly and of course the capacity, the astronaut hours, because using Bartolomeo, the payload will be placed or prepared inside the ISS. So we have to get the astronaut hours. So all these ISS services, the current one, which are available on the ISS, we can access them and propose it to a customer, of course.
Okay. What kind of applications would you think for this product, or do you already have some like good examples?
Yes, we have seven customers we have signed. We have, of course, the large, I would say, European Space Agency, so ESA, DLR, and CNES, and mainly focusing on scientific or technology payloads, mainly large payloads, so biological experiment, material exposure.
Okay, we either lost Yannick or we lost me.
Yannick.
Okay. Well, that's too bad.
Okay.
Oh, yeah. Now you're back.
Okay, sorry. Yes, I was saying. So we have application, biological experiment, material exposure, or even for the DLR technology demonstration of the atomic clock, for instance. But as well, we have some startups, and for as well as technology demonstration, like laser intercommunication system, or startups starting with other business for Earth observation, for instance, as we consider that Bartolomeo is a very affordable solution. So yes.
Okay.
But we have no limitation in terms of application. Of course, we are using the ISS, so we have a constraint of the orbit. So we cannot do everything, but we have a very large panel of possible application. Yeah.
Okay. So from people can actually apply for this, and then.
Yes, we can visit our website, Airbus Bartolomeo. We'll make a presentation this afternoon, mainly focusing on one part of Bartolomeo, which is the Argus. So small payload adapter, focusing on small payloads, focusing on starters, focusing on what we call usually the new space. But it's quite easy, and we are very reactive because we have a small team within the organization of Airbus Space System and Space Exploration. So they are very, very reactive, and as we have a standardized product, and we said a standardized offer, so we can react very, very quickly.
Thanks for having time to share with us.
Okay, thank you, Marcos.
Thank you. I believe the next company would be Icy Space and Abe Bonnema.
Yes, hello.
Hello. So Icy Space, who are you? What do you do?
Yeah, let me see. Can I share my screen, you think?
Yes, I think I can, and I can hear you also.
All right, let's see. The question is always, do you see the presenter mode or the right one?
Now I see the presentation also. Yes.
Yeah.
Okay.
But yeah, so let's stick to that. So very briefly, in a nutshell, because I don't want to steal all the time from my dear friend Emil, who is still waiting after this.
Yep.
So who are we? We are Icy Space, and we are a vertically integrated company specialized in small satellites. Started in 2006 from Delft University as a spin-off. And meanwhile, you could call us the CubeSat dinosaurs as part of that group that started so early. And we do everything with CubeSats. We build components, we build complete missions, that's our bread and butter, and we do launch services and everything on the side. So I can skip through, meanwhile, while we're talking, I'll skip through some of the slides of the presentation. We can talk afterwards with people if they would like to know more, but the key point is elements, missions, moving towards satellite as a service.
So yeah, so you have a wide-ranging mission building capabilities.
Yeah, correct. So when we started in 2006, there were not that many companies really involved in building the CubeSat components yet. So we were forced to build a lot of that ourselves. So that's how we started off, but all with the aim to build full CubeSat missions. Which we now build, you can see in the background, CubeSat buses in all sizes and variants. Ironically, the space CubeSat world going a bit up again in size. So we see more and more 6 use rather than 1 use. And yeah, that all has to do with the capabilities of the technology on board, of course.
Yeah, obviously. Services, mission design, payload development, launch services, environmental testing, training.
Yeah.
Okay, so basically I can walk to you with an instrument and say I want this into space, and
exactly
the rest. Okay.
Yes, exactly. So that is part of what we do for a few customers. I'll actually skip to a few later slides where people can have some example customers that we are happy to mention. There we go. So for instance, for Kleos, which is one of the startup companies more in geolocation services, we have had the honor of building 4 of their satellites, which were recently launched. And they had a need and a specification for the payload, for which our team did the full design together with partners on the payload and on the software. We integrated the satellites. This was quite a bit of a challenge to do that within 6 months, and then launched them on Transporter 2 in June. And they're now being commissioned and will be handed over to the customers.
That seems like quite a fast schedule for development.
Yes, ideally that would be a bit longer.
Even so,
this was the time that was available.
Yeah, but that kind of short schedule is only possible with experience.
Yes, and indeed within the CubeSat realm, and with not too many showstoppers.
Okay. How do you see the market developing now?
Well, really, indeed, I think what is important, what we see as well, having been around for 15 years, and I think you see that definitely in Finland. I always like coming back to this conference, the workshop, and see the new developments. We've left the CubeSats as educational tools to become more performance-oriented, actual items with which we can do something. Something being like really useful missions in terms of constellations. and the data need of what we have. And we've seen other talks during the conference that are all oriented towards that. Definitely a lot of knowledge on data processing within Finland, of course. And that data need will only increase. So that's where we see this market, the small satellite market particularly go, which enable more and more applications that gather data, whether that be on climate change or whether that be on other types of monitoring. Definitely we'll see a lot of that on both commercial and institutional basis coming.
Yeah. Okay. Your company capabilities are pretty impressive, I must say.
Thank you.
Thank you for having time to be present here with us.
Of course, yeah.
Will you have a breakout room?
Yes, I have one to which I will go back now. So if anyone wants to follow up, I'll see them there.
So Easy Space can be found from their breakout room, it seems.
Yeah.
Okay. So thank you for having time for us, and then our last guest will be Emil Winterhav from PASQ Space.
Hello, Marcus.
Hello. First, I must ask, how do I spell that, the name of your company?
PASQ.
PASQ. Okay.
I hope I'm not insulting anyone in some strange language now, but...
Well, in Finnish, that it requires some carefulness now, but...
Okay. That's good. It stands for Paraspere space qualification anyway. So through some difficulties, we reach space. That's the idea.
Okay. Yeah. So what do you do? What is your company?
Our idea with the company is to help ideas into space.
Okay.
So company comes with a brilliant idea for AI or for embedded systems or for observation, and we help get the idea into space. And our focus is on making things work in space through qualification.
Okay. That's interesting. Do you have like business cases already present, or are you very in the beginning stages? Are you like a beginning startup? Do you have like some examples from the past?
We've been around for a while, about 2 years. We just qualified from ISABIC, or we're now an alumni from ISABIC in Sweden.
Okay.
And we have mainly focused so far on radiation testing.
Okay.
We offer mechanical and thermal testing and also starting to offer EMC testing as well. But also on the other axis, we're also offering a radiation design approach and support for radiation engineering, including analysis. So we do that to smaller company and bigger companies. Typically, we're in the new space industry. With where ideas and there are new ways of working, and there are sort of in the process of establishing new ways of to do things in the organization. Yeah. So that's where we are basically.
Okay, fine. Radiation testing, you said.
Yes. So
no. How? What kind of radiation, and with what kind of facilities?
Yes, we have a network of facilities around Europe, I should say. Both in Sweden, but also in Poland, Germany, Netherlands, Switzerland, and Finland, and also Norway. And we have a number of possibilities for cobalt-60 TID testing. We have a number of sources for proton testing from 10 MeVs up to 200 MeV that we test. And we have actually brought online a number of facilities that are not typically used for radiation testing of equipment.
Okay.
There's a lot of biological test stations around there, and we're using them for space. And also we're working with your guys. We're starting to work with your guys in Jyväskylä for heavy ion testing.
Okay. I believe the proton testing happens with particle accelerators, synchrotrons, or?
Absolutely, yes.
Yes, and the cobalt-60 source is like a radioactive source then. As I mentioned,
cobalt-60 is a radioactive isotope, and there are a number of facilities, but not all are open for precise irradiation of equipment.
Yeah, and that's like from technical perspective, it is easy to imagine how that works. But in my experience, having cobalt-60 samples for that kind of purposes is in terms of like the paperwork it requires. That makes the cobalt-60 sources rare.
Yes, and we work with the partners in all for our sources basically. So we have a source in Sweden that is a government source. I think it's maybe difficult to own a radioactive source as a commercial or private entity in Sweden at least, and probably throughout Europe.
Yeah.
So that's why mainly all sources are institutional somehow.
Yes, because
I might be corrected.
60 is a particularly nasty in the wrong hands, but very very necessary for this kind of testing for space industry. So
yes, it's one of the stock tests we do.
Yeah. Any other important capabilities you have?
Yes, recently we've started to do this analysis and support of radiation engineering or radiation design of equipment.
So
and I think shielding, but also selection of components and analysis of local TID loads and SE rates and components, those sorts of analysis that are important and complement the testing very well. So you cannot typically test on component level, and then you make inference through analysis of what the effects of the radiation will be, and then in some cases and for some aspects you can actually test on the equipment level what the effects of the radiation is, including for total dose, but also in some extent on proton testing on equipment level. You can see the response of some types of single event effects, and we do those as well.
Yeah. Well, thanks for having time to present yourself here.
Oh yes. Now I'm happy to. We've helped. I should say also that we've helped a number of companies on this. We have a big Japanese company, and that we helped. You would know them if we mentioned them, but we are not allowed to.
Okay.
Trust Me is one of our companies as well that we've done some work for, and now we're working for a Hungarian company.
Okay.
And you should check out the job offering that we have on LinkedIn at the moment.
So you are recruiting like most companies here, I assume, are recruiting.
Yes. Yep. That'd be great. It's easy. One click away to do your application.
Yeah. Okay. Nice to hear that. Okay. Thank you for participating with us.
Yeah. Thank you.
So that will conclude our last industry hour here. We are a bit over time now, but we had very interesting guests. So without further ado, you can go and see them in their industry rooms.
Thank you very much, Markus. That was excellent. That was really interesting talk. And now we have time to go further with our program. Next in our program is plenary session. Starts 15 minutes after 2 o'clock. And we have 2 presentations. Both presenters are already online. The first presentation will give an overview of the mapped needs, what needs to be done and what kind of small satellite needs Finland have in the future, and what kind of ground segment we should develop for meet these needs. And the second talk given by Isai and Darren Muff is about the latest news in the Isai SAR and data providing front. So the first presenter is Timo Ryyppä from Sodankylä. Timo, are you already online?
Yes, I am. Yes, I'm online.
Excellent. That is very good. So I had an interesting chat with you already. Where you are located at the moment?
Well, as you say, there were few variables. So that's why at the moment I'm at the Rovaniemi airport and it's the old air traffic control tower. So I'm giving the presentation from here.
That's impressive. That's impressive. So our digital world really penetrates to really odd places. So I would not have been thinking this place in order to give a presentation. So can you give a very short background why this kind of study was overall done in Finland? And now we are talking before the presentation. Of course, you are giving also the presentation as well, but just to tickle a bit our audience and get the small background of the presentation.
Oh, yes, so maybe I should also put my video on. Okay, hope the Zoom won't crash like it has been done for several times, but yes. Hi. So I think no one has ever mapped the and collect the needs from all, or at least almost all, the actors in the Finnish small satellite business. So I think there was actually a need to collect information from different sources and put them together and see how Finland as a rather small country should go and maybe act together to aim even something bigger.
That is true, and especially if we look at our neighbors, Sweden and Norway, they have been, I would say, taking a much better advantage on the northern location in terms of ground segment business, and both in Sweden and Norway you can see really lucrative activities in the ground segment, and a lot of our own satellites are using also Norwegian or Swedish ground facilities.
Yes, that's
so.
That's
But can you also give a very couple of words about what do we have at the moment in Sodankylä?
Well, at the moment we have 3 X-band antennas that can receive in X-band, one 2.4 meter and two 7.3 meter antennas. And in addition, one of those antennas is able to transmit in S-band. So basically we have everything in our hands, but now we just need to start utilizing it more, I would say.
Okay, so thank you, Timo. I ask you to share your screen and start your presentation of this afternoon plenary session at Finnish Satellite Workshop 2021.
Okay, thank you. So 1 minute ahead. So okay, so as Jan already introduced, my name is Timo Ryyppä, and I work at the Finnish Meteorological Institute at the National Satellite Data Center in Sodankylä, that is part of the Arctic Research Center. And the presentation is the results of our project. That name was I would say a little bit horrible: development and investment needs of the Sodankylä National Satellite Data Center to support Finnish small satellite activities. But as you can see, the name clearly describes what we did. This was funded by the Regional Council of the Lapland, and the whole study was actually carried out by organizing a questionnaire, doing some interviews, and then collecting information and, for example, sending requests for information to different antenna vendors. The final report is available at our webpage, at the FMI Arctic webpage, but unfortunately it's in Finnish. But if you find this presentation useful and want to get more information in English, please contact me. Okay, and for the questionnaire, we contacted about 20 parties in Finland that were known to have small satellites, or we estimated they would have small satellites in a near future. And in total of 9 participants answered to the questionnaire, and big thanks to all of them. So I think we got a very good coverage of the Finnish small satellite activities. The questionnaire that was divided into 4 teams, and the technical requirements and needs, they were even divided in more details and covered separately the satellites and the ground stations. And next, I will show some, I would say, the results of what the Finnish small satellite activities and actor and sector looks at the moment. So first of all, the current state. So most of the activities is focused on the southern part of Finland. And as you can see, the number of employees working in the field of satellites is, I would say, rather small per company. But pay attention that in this number of employees number, it doesn't represent the number of the total employees in the company or institute, but only the persons that are working with the satellites. So that's why it's not the total number. And then we map the current state that do they have a small satellite flying? So 5 out of 9 had an active small satellite. So basically the satellite was flying. And this was the state at this spring, because now there has been some few launches, so this number might have changed a little bit. And out of those 5 satellite operators, about half and half had their own ground station, and the rest they used some external ground station, or both the ground station had a ground station service, so they didn't own the ground station. And of course, those who didn't have a satellite, they didn't have a ground station. About the current and future satellites, the S-band and UHF band were the most popular for communication. And in this, the S-band doesn't include the amateur frequencies, so this is excluded. Polar orbit was the most popular orbit that the satellites are or will be. And at the spring, there were the planned launches of these participants to the questionnaire. There were planned of 4 launches this year. And for the 2022 and 23, in total of 5 planned launches. And the mission lifetime for the planned satellites or the current satellites, half were less than 2 years and half were more than 2 years. So they were evenly distributed. And the satellites, they wanted to have like a daily data transmission to ground stations. So they were, I would say, actively used, that you just don't take in 1 image per week, but you will daily use the satellite. And about the ground stations and their needs, about 50% of the participants said that the northern Finland would be an ideal location. But also in addition, there was a need and a will to have the ground station next to the satellite operator premises. So, for example, for the educational purposes, it would be wise to have the satellite just next door and not, for example, 1,000 kilometers apart. Even you could access it remotely. Most of the actors, they wanted like a full capable of ground station. So they wanted to receive and send data. So not just only receiving data. And about the availability of the ground stations. So if you agree that the ground station will acquire some data at some point, they wanted it to be that the availability is 99.5% of those agreed contacts. So that's actually rather high and makes lots of demand for the ground station and their equipment. And if an external ground station was used, the need how fast the external ground station must react to the satellite operator request varied a lot from seconds to weeks, so depending on the situation. Okay, and the resources and experience. So most of the participants, they had already spaces where to build satellites and ground stations, or they will have in near future. Master of Science in Technology or some other technical or engineering degree was seen most suitable to work in this field. And also the interest and hobbies in electronics and softwares, it was emphasized. So not only that you are good in school, you need to have like an interest in what you're doing. And then there is on the right-hand side is the experience on building the ground stations, that how many years people have built the ground stations. And about half of the people, they have building more than 5 years. And these numbers were almost same for experience on building satellites. I'd say the main results of the study was that there were 2 types of antennas or ground stations Finnish small satellite actors need. So one was then like a combined UHF VHF S-band ground station, more for our research and demonstration purposes, and especially using for the amateur frequencies that actually requires some licensing, that you need to be a radio amateur in order to operate this kind of ground station. But we found it hard to find a provider who would provide a 3-band solution, that it would cover all the bands, and especially the bigger players in the world, they didn't find this like a good business for them to start creating amateur frequency band stations. Another need was an S and X band ground station, and it would be more used for operational commercial operations that require some time criticals and security. But of course, if you need for example, transmitting S-band, you need a license from the Traficom, and that license need to be coordinated with the neighboring countries, and that can take time. And a turnkey installation for about 3.5 meter X-band antenna, the prices start from $500,000, and basically there's no upper limit. So if you want a very redundant, everything doubled, and want to buy the state-of-the-art system, so basically you can put as much money as you want. And to fulfill these needs, we created 4 possible scenarios for NSDC to fulfill the needs of the Finnish small satellite activities. The scenario 1 was that there was a mostly self-built, co-owned small satellite. So FMI together with some other party would together build an antenna. And the estimated investment cost is about 100,000 euros, but this cost excludes the labor cost, so it's just a pure investment. And maybe I would say the scenario 1 is the most likely. Then scenario 2 is the NSD fully owned small satellite ground station with turnkey installation. So we just bought it from the market and then received it completely ready. And as you can see, the price is already a little, I would say, much higher. The other 2 scenarios is duplicating our current S-band capacity to have the 2 S-band transmitter, but unfortunately, that might be not the best option for the Finnish small satellite actors and activities. And the estimated price is even more higher, and so you need to add 1 0 to the end of the sum compared to the small satellite ground station. And well, scenario 4 is that I would say we don't do any investment, but try to better utilize our current capacity by offering our services through API and utilize more, better our antenna time. Okay, and then last thing, so I said we have 3 antennas, but soon we will have 4 antennas. So we are at the moment building SOD03 and antenna that is working in L and X band, and we are preparing for the EUMETSAT METOP 2nd generation that Jochen was telling yesterday, and we also plan to use that antenna as a part of the EUMETSAT EARS service. And as you can see from the picture, this is just from this morning, 11 a.m. We were able to erect a steel tower, and soon there will be antenna on top of that tower. Okay, that was all, so thank you.
So thank you, Timo, very much. We have a time for one very quick question. Is there a question by anybody about the small satellite antenna in Sodankylä? If no one, I would ask, like, if we start to build, let's say, this autumn, these capabilities, how long it would take to actually get something which is working already?
Well, of course, it depends. Will you start from the scratch and develop everything from yourself, or how ready components you will buy? So, of course, there are lots of components out of the shelf. So, but it needs to it takes some time to get them operate together. So, well, hard to answer, but of course, we could start.
So,
Jan, may I ask?
Yes, one quick question and then we have to move forward.
Yeah, so this is Tommy from North Base. Hi, Timo.
Hi.
Great to hear from you, and it's nice that you have made all this market study, which is also useful for North Base. So we have been discussing before, I mean, FMI and North Base, and as you know, and as you know, we're building a ground station now for UHF and VHF for Tampere, operational in about 1 or 2 months, and then we'll continue at Muonio, first quarter next year. So we will have this capacity. So I hope that will be, taken into account when, thinking about public investment needs, stuff like that. We're doing this on private basis, but we would very much like to discuss with FMI or continue the discussion with FMI. This is a good plan. Thanks.
Okay. Thank you.
Okay, thank you very much, Timo. And we are moving on with our program. And next, I'm really glad to greet here Darren Muff from ISI. And Darren is going to give a really fast overview of all the multitude of things which are happening at the same time with everything else in Finland. Just the next building from Aalto from here. So Darren, be my guest, take a floor and give the fresh news out of the horse's mouth, like they say.
Thanks, Jan. I'll do the obligatory. Can you everyone see my slides okay?
Yes, we see your slides very nicely.
Okay. Yeah, so as Jan said, we're right next door to Aalto. My name's Darren Muff. I'm the Senior SAR Product Manager over at ISI, but actually this is a work from a bunch of people. I'm representing Vladimir Ignatenko, Leszek Lamentovsky, Matthew Nottingham, and Andrew Radius. And as Jan said, what I'm going to talk about is some of the 2 cool new features that we've developed this year. That's part of the ISI constellation at the moment. So I guess before we go too far, just to make sure that we're all on the same hymn sheet, this is what synthetic aperture radar looks like. It's basically, we've got a bunch of satellites on orbit. We fire pulses down at the ground, about 4,000 pulses a second for 10 seconds at a time. We downlink the data, and then we process that data to make it look like we've got a really long lens in space, and that gives us our resolution. But the cool thing for us is that we get to see through any weather conditions, and we get to see at nighttime as well. So it's a very potent and scientific measuring device and imaging capability from space. And our roots, as Jan said, are intimately tied into Aalto. The company span out from Aalto many years ago. We owe a lot to Aalto and to Jan specifically for our heritage. This is one of our earlier radar systems. The panel on the left-hand side there is actually the antenna. And this was flown on an aircraft system. We first used this for imaging ice packs. And that evolved to this is ICEYE X1, which was launched in the beginning of 2018 in January. And then actually this year, we had two big launches. In January the 24th this year, we launched 3 satellites on the SpaceX's Falcon 9. And then later in June, we launched another 4 satellites, which means we launched 7 this year. And right now, ICEYE, it's a very small Finnish company, has got the largest number of synthetic aperture radar satellites in its constellation around planet Earth right now. Okay, so let's talk about the challenge. So before we started this project, this was our main arsenal. We had 2 main imaging modes. We call one a strip mode, which is a larger, coarser resolution, 3-meter resolution, able to image an area about 50 kilometers by 30 kilometers. And then we have a spot mode, which we use a fine resolution, which was 1-meter resolution, which is smaller, 5 kilometer by 5 kilometer scene. And what we really wanted to do was to do a scan mode. Now, the reason why I want to do a scan mode is it's actually what a lot of the larger satellite providers provide. I should have mentioned our satellites, as you saw, are very small. They're less than 100 kilograms, rather than the several tons of mass that the larger SAR satellite providers have. And it's a lot easier for them to hoover up large areas. And we wanted to see if we could come up with a way to do this from our small satellites. I want to explain to you, I guess, some of the technical side to that, rather than just showcasing what we can do. So to recap, when we do a strip map collection, we actually fire a radar beam down to the ground. The satellite moves towards the right in this graphic. And it's important to recognize that the beam that we shine onto planet Earth is not consistently bright. It's brighter in the middle and then it fades off towards the edges. And so when we make a standard strip image, what actually happens is we form a synthetic aperture which is consistent with the amount of time that a point on the ground passes through the radar beam. One way to think about this is the size of the lens in space that we use to form the pixels. But we end up with a swath, which extends in azimuth and range, which fades out towards the very edges, but in the middle is consistently bright. Okay, so the first step we want to try to do to make a wider area product is to do a bit of research on this. And the most popular way to do this is called ScanSAR. And this is in a cartoon way, really how ScanSAR works. We're very fortunate in one way, but we've actually done a lot of thinking and designing on this. And our antenna, as you see on the top right-hand side, is not a reflector type antenna. It's a 2-dimensional electronically steered phased array, which means that we can control where the beam points on a pulse by pulse basis by adjusting the phase to the various elements on the back of the antenna. And so with a scan mode, what we can do is we can shine the beam at a point on the ground, and then we can actually increase the elevation to illuminate a part on the ground further away in range, and then a third burst, and then a fourth burst. And then we repeat back to the beginning, and we actually keep striping the ground. The synthetic apertures are slightly smaller, but it does allow us to actually cover a larger range extent than we could normally with a strip mode. But there's a problem with this. And the problem is that because points on the ground don't go through all the beam themselves, there are areas which are brighter and darker. And this is often picked up by larger satellite providers who can spend a lot longer time to be able to apply beam corrections to their, first of all, to measure what their beam is. Sometimes it can take 1 or 2 years to do that properly. And then they can correct for that and make it artificially brighter so that you get a nice polished image. Unfortunately, ICEYE doesn't really have the luxury of spending 1 or 2 years to do all the calibration. We have a big demand for our satellite resources, and obviously selling images is where we're at. And also small satellites, we don't really know yet how long they last. We're thinking about 3 years or so, but it might be that they're a bit shorter than that. So rather than doing that, we came up with another way of doing it. I just wanted to show you the first ScanSAR image, which highlights where these dark areas are. And you can see this isn't a really good product. So what we came up with was something which was developed many years by other people, not us, called TOPSAR, Terrain Observation by Progressive Scans. And in this case, what we actually do is we, as well as transmitting bursts, we actually scan the beam from back to front for each burst. And by doing this, we actually progressively make sure that everything on the ground is illuminated in a consistent manner. And by building up our image by firing these bursts and scanning the bursts over the ground, we end up with a unified large product. It's a lot more complicated to process, as you can imagine. We have to very precisely calculate the scan rate and the burst rate, and we have to apply the phase corrections across the entire antenna. And then we have to piece it all back together on the ground. But it actually makes a better product for doing scan mode. And this is actually one of our first scan images. It wasn't the first, but it was. I chose this one because it was in the news. Everybody remembers the Suez Canal being blocked up by the merchant vessel Ever Given. This is a picture of it down there, and we've got the Suez Canal with all the vessels all blocked up on the right and the left, who can't get through because of the blockage. But I wanted to do something a bit different this time. I wanted to give people a feeling for what synthetic aperture radar was like. And so this is actually twice speeded up real time. So this is twice as fast as it actually is. But this is the entire scan moving over that Suez Canal. So you can see the Suez Canal. It's about 500 kilometers from one end to the other, with east and west, left to right. And you can see the ships all blocked up there. You can see the vessels in the canal, and then all queuing out behind them again. And that sort of gives you a feeling for the area that we can cover. Remembering, of course, that this antenna is only 3.2 meters long and our satellite is less than 100 kilograms. It's the first time we've seen that being performed on a small satellite before. And we've got some quality metrics there, and I'll leave them in the charts, and people can look through them and ask me questions about it later. Because I want to explain the second thing that we've developed this year. And that is, we've moved a few of our satellites into a precisely repeating orbit. It turns out that by changing the altitude of the satellite, as hopefully most people in this conference realize, that changes the orbital period. And you don't end up with a precise integer number of orbits per day. We tend to have about 15 orbits per day for us, which means that if we actually wanted to precisely repeat every day, we'd have to have an orbital period of 96 minutes. It turns out we're usually 96 plus change, or maybe 95 plus change. We're not quite there. But ICEYE satellites have got an ion propulsion system, which doesn't use cold gas, which means that we've got a near limitless supply of propulsion. It's not very, doesn't have a large thrust, but it's got a large specific impulse. Which means that we could change our velocity and then change our altitude, which means that we can very precisely tune our orbits to be exactly 15 orbits per day. Now, just think about this for a second. What this means is that if you were to take a picture, say, of Helsinki, that first image, and then we took one again tomorrow, the satellite would be precisely in the same location as it was today. So they take the image at the same time, but the satellite is also able to image in such a way that the entire geometry for the scene is identical as well. And this is an example. This is a 10-day period over the Muldrow Glacier, actually 14 days, Muldrow Glacier, where every single day we've taken a SAR image at the same time, and the geometry is completely consistent. And it allows you to see the flow of the glacier moving down the valley there. But there's actually another part to this, which is where we really think the money is, and that's this. this is something called coherent change detection. So because we can position the satellites to be very accurately in the same location, and because we form the images in a coherent manner ourselves with software on the ground, we can actually combine compare the phase information inside a pixel from one day to another. Now you have to remember that the phase is a fraction of the wavelength, and our wavelengths are 3 centimeters. Our resolution is 1 meter. So we're comparing changes which are far, far smaller than within one single resolution cell. And the way to look at coherent change detection imagery is anything that's white in this image means there's been no change from yesterday to today. And anything that's black is either a shadow, like some of these areas, or changes that have occurred on the ground. And by stepping in time, you can see changes that occur caused by the pattern of life. For example, a track as somebody walks across the grass over here, that you probably wouldn't see even if you were stood next to these features. And we get to do this from 800 kilometers away in space. So that's kind of powerful for us, and we're going to be using this a lot more in the future. I just wanted to provide a quick summary of those things. It's if anyone is interested, this is the current constellation status at the moment with our strip spot scan capabilities. They're on the slides for people to see. They're also on the ICEYE website if people want to look at as well. And that's it from me. Are there any questions?
Thank you very much, Darren. It's absolutely staggering amount of progress what you are doing. Your SAR system is not shy anymore of any other system in the world. You are outperforming any free data in the world already. And this is the first time I actually see daily based coherent change detection from SAR, from space with any type of civilian system. So this is a feature which has never been available even with money before. So this is an absolutely beautiful development. So if I have a first question here, so how many of your satellites are able to do this already, and how the future looks? How many satellites you plan to have this kind of capabilities?
It's a good question. Right now we have 2 satellites in one-day coherent ground track repeat orbits, and the plan is to move them all eventually to them. So we'd have 18 satellites all in the same coherent ground track repeat, and that means that we can cover all the world as well. So as you can imagine, each satellite in one of these orbits sacrifices the ability to see everywhere, but by having 18 of them, we get to see all the world, so we can choose anywhere.
Okay, this is really, really important and interesting. And I really think that these are the sort of killer features what you have now in your sleeve in order to really tackle the market with something which is just not available by anybody else. Do we have any other questions?
Good, I'm glad.
I could have one. This is Samson. I believe you are in the process or even completed the process of becoming a Copernicus third-party mission. So how does that work, and what can I get, and what kind of data do you provide there?
So we're going through Copernicus contributing mission status at the moment, so we're not quite there yet. But we're also a ESA third-party mission status now. That was granted to us earlier in the year. What that means is that for researchers, if you got a research proposal, you can get ICEYE imagery for free. And basically, you put your proposal into ESA, then ESA then gets the data from us and then gives it to the students. The CCM status, the Copernicus contributing mission status, I believe it's due to occur sometime in the beginning of next year.
Okay, thank you.
Any other questions?
Yeah, hey, thanks for the talk, really impressive. So you mentioned this, that you do the orbital corrections to keep 15 orbits a day. So once you achieve the desired orbital period, do you have to keep it quite often, or you just do orbital maneuvers every now and then?
That's a great question, Andrei. So the key thing, what you want to try to achieve is a frozen orbit. And a frozen orbit is where you actually adjust your eccentricity and your argument of perigee, so you don't have to do the orbital maintenance. We're not there yet. The reason for that is we've got such a demand for this that we just haven't had time to be able to do that, put the satellites into that configuration yet. We're going to have to do that. But for now, what it means is that we do orbital maintenance maybe every 2 weeks or so, just to keep the coherent baseline within about 500 meters.
Yep. Good stuff. Thanks a lot.
Any more questions?
Yes, hello, this is Eija Parmes. I would like to ask if, because the natural disasters increase year by year, as we all know, and it would be very, very important to detect and prepare as fast as possible. So do you have plans or projects in that area?
Actually, yes. I probably did a large part of the company a massive disservice because I just talk about the geeky satellite stuff. But a big part of ISI is actually doing just exactly what you said. We've been doing some really impressive flood analysis and flood detection recently. And also we're tracking some of the wildfires as well, I think in Australia and the US. And so I think the support to humanitarian aid and disaster relief is something that we really feel very strongly about in the company, and we want to try to make sure that our forward direction definitely includes that. That's kind of one of our raison d'etre, one of the reasons for us to be here.
Thank you.
All right. One last question, if anybody has.
Okay, this is Henrik Kahanpää. Okay, so I have a question about what about rescue missions have you been involved in? Like, okay, you can see a single boat on the sea, so have you been involved in mission in operations where you are trying to find a missing boat or something like that?
Not that I know of. I think it's a really good idea. Certainly being able to search the oceans for example, like the Malaysian airline accident where an aircraft crashes. That's something that we should be able to do a lot better in the future. But I'm not familiar. I don't know that we've actually done any search and rescue type missions just yet. I might be incorrect.
Okay, thank you again, Darren. That was a very exciting news from ISI, and I hope we can all download some of the example data sets to play around with students and try to graduate more people and students in remote sensing. But we will go further with our program, and next 3 sessions will start in 10 minutes in breakout rooms, and upcoming sessions are, the first one is biodiversity and climate change. Of course, many of the presentations are directly or indirectly are related to climate change and biodiversity, but we like to emphasize this topic by having also a special session about that. Yrjö Rauste will tell about European forestry stakeholder requirements for remote sensing of biodiversity, very important topic. Then Anna Kontu will tell about modeling of forest vegetation optical depth for microwaves, for L-band. Then we have Jukka Miettinen telling news about new forest carbon monitoring program. Paulina Rajavits will tell about leaf level studies to facilitate precise interpretation of remotely sensed sun-induced fluorescence, which is related to biodiversity as well. And then finally, Victoria Sofieva will tell about long-term trends in stratospheric ozone, evaluating or using the LIMB satellite instruments. So as you see, it's a variable set of presentations which are taking different angles on the same problem. Then we are going on also with our onboard imaging session, and we have, for example, a presentation by Daniel shares about Janus, a NASA Simplex mission to explore binary asteroids. This is a small satellite mission idea, very interesting. Then we have another really interesting idea popping up from Tartu University, and Aldo was involved at least with Andris at some point as well. N-space concept, so how to navigate near to uncooperative targets in space. This can be applied both to space debris and also applied to asteroids and other targets. Then if somebody is not knowing about Hera mission, so I really recommend to listen also the presentation about Hera mission. Hera mission was many times mentioned during this onboard imaging session already. And then we have a presentation about Mario Palos about realistic visualization of solar system small bodies using Blender via ray tracing software. And this is a bit like a CISPO system. And the last and not least is a bit different presentation. Maria Hieta from Finnish Meteorological Institute will tell about Minipins, a planetary sensor package, which hopefully will find its way soon also to other different missions and planet surfaces. And it is in onboard imaging session because it actually has imagers on board as well. And then we have a session also about payloads, and we have some really futuristic things in this session. For example, thinking about 6G satellites. Marko Hötöä from VTT is telling about what kind of requirements these new satellites pose for the actual satellites. Then there is a presentation about multi-payload external platform on the ISS, Argus. Then Medipix Timepix radiation payloads for ESA developments by Carlos Grania. And then we have an interesting presentation about organs in space, so how to bring a medical or biological material to space. And finally, a keynote about Millilab and a talk about how the future design of small satellites for science missions and millimeter waves are connected. All right, so I hope all our session rooms are already opened. You can go to your session rooms and start practicing. Can you present your slides as well? And I from here wish everybody very interesting sessions and trying to join as I can here some of the sessions myself as well. In this main channel during the sessions we're going to have our industrial partner videos rolling, and so we can learn also a bit more about what industry is doing. So have a nice sessions everybody, and after this session we are having a short break, 15 minutes, and then we go to the final interactive session where we have around 20 different papers which you can, or where you can interact with authors directly. So have a nice sessions and see you here about an hour.
Within our electromagnetics business line, we develop antennas for various applications. Here is one example, an antenna for the radar altimeter of a planetary lander. Harp Technologies provides technology and R&D services in RF and microwave engineering within 4 business lines. We support our customers in various application domains. Harp Technologies, at your service.
The evolution of technology, like, it doesn't happen automatically. The evolution of technology and evolution of humanity, only happens if somebody does something about it. When you look at space technology as a whole, it's very easy to see that as the sort of next frontier of technology, next frontier of humanity.
The globe has always been on the move. Until now, we really haven't been able to capture that continuous change that keeps on going in front of our eyes. ICEYE has developed a completely unique technology. It's a synthetic aperture radar system mounted on a small satellite and allows us to see through clouds and darkness any place around the globe. And that sort of data stream was unavailable before. The persistent monitoring that is available with ICEYE's technology it's the first truly global ability to look at things on daily and sometimes sub-daily basis. We can have hundreds of locations being imaged every 12, every 8, every 4, 5, 6 hours, and we can get that data stream to us continuously.
If you go from the scale of weeks to days or weeks to hours, you are enabling the idea, oh my God, for the first time, we're actually looking at potentially predicting avalanches, potentially predicting volcano eruptions, predicting massive earthquakes, predicting building collapses before they happen.
You can't allow the ability to miss what's going on. How could we ever build a reliable flood monitoring system if we couldn't guarantee the ability to measure the water depth, regardless of what's happening on the ground? What if we missed a flood? Then our system is worthless.
This is why we wanted to bring available what's called coherent ground track repeat. And we wanted to make it daily so that every day you can get a repeating ground track image acquisition on the same location that allows you to do these millimeter level change detection on every 24-hour basis.
It's a new way to observe the life on Earth because it's the first time that really we can reach anywhere and anytime.
As a leading space technology and intelligence company, Maxar helps customers unlock the promise of space to solve problems on Earth and beyond. Whether it's collecting geospatial data to help organizations build reliable maps for their consumers, providing the intelligence governments need for national security and sound decision-making, or building spacecraft components that will send the next astronauts to the moon and beyond. Our capabilities in space infrastructure and Earth intelligence turn big ideas into successful missions.
We have been on the far side of the moon. We have explored a comet and been in orbit around Mars. Today we are on our way to both Mercury and the Sun, and will soon begin our journey to Jupiter and 3 of its icy moons. At IRF in Kiruna, we have been developing instruments for space missions for over 60 years, and in that time, much has changed. The space industry is now open to many more stakeholders and is expected to grow rapidly over the next few decades. There is an increasing need to test and calibrate new space technology, and that is exactly what IRF Space Lab can provide. Space Lab is a constantly expanding facility with the aim of continuing to be in the forefront and to develop according to the growing market. As a step in this process, we want to broaden our network of customers and partners and share with them our knowledge, passion, and ambitions. Take the step out into space with us.
Space and its technology continue being a key element in our society development despite COVID. At both ESA and European Union, there are many missions directed to improve human being lives. Europe recently had its largest budget ever approved since its history, and there are a huge number of missions like Copernicus, Ariel, directed to explore exoplanets, and many others. Other countries such as United States continue investing huge amounts in projects such as Starlink, NASA supporting and leading many different missions, customers like Boeing, and many other organizations that are recurrent customers to Alter.
So Alter Technology, we have recently developed multiple self-service digital tools for our customers. So the most relevant one is a digital database for EEE parts that is based on big data technology. And then we have two digital tools that are intended for the customers to follow up on their purchase orders. Okay, so the first one allows them to check the whole procurement process so they can see information related to their logistics, the finances as well, and all the documentation of their orders. And then the second one allows the customers to perform the real-time monitoring of the testing activities. Then recently, we have developed a virtual platform, a consultancy platform that is intended for consultancy services. So then the users can send us their consultation requests for us to address them and give them the best solution.
Communication systems have become a key element in today's world where virtual events and virtual meetings take place worldwide. High-speed digital systems, microwaves, and optics systems merge together to meet the requirements of a growing demand for high-capacity links. Alter Technology combines its expertise areas to meet the requirements of future communication systems.
So space continue being in the trend, and Alter is just there.
The world is slipping into post-factual existence. It's easy to make assumptions, take action, and go wrong.
I think there is no climate change at all.
I'm pretty sure I'll stop global warming if I stop using plastic bags.
I don't think there's such a thing as responsible forest management.
I'm not sure, but I think my food is produced organically.
Polarization of issues happen because of assumptions. We are on a mission against that. The technology we use monitors the environment from space. We collect and combine facts that you can use to start action. Our range of experts leverage creative technology to make an impact on things that really matter. Stop assuming. Try facts with us.
DA Group is a technology company. We have been in space business about 40 years. We provide advanced electronics and radio frequency solutions and products for major space companies on a global scale. DA Group delivers equipment and subsystems for space applications, including all phases of development, design, manufacturing, and testing. We maintain strong prototype and in-house design. This enables us to provide unique and complex systems for the space applications. Currently, we are building systems for more than 10 satellites. We have a large clean room that enables us to provide large-scale manufacturing on the small satellites in series. Our aim is to make space everybody's business.
Tällä hetkellä avaruudestahan on tulossa ihan kansainvälinen megatrendi. Ja koska sinne lähetetään uusia satelliitteja niin paljon, niin on myöskin tärkeää varmistaa, että sen avaruuden käyttäminen säilyy turvallisena. Me kehitetään sellaista uutta radalta poistoteknologiaa. Toisaalta me halutaan, että näiden satelliittien käyttöikä pitenisi. Ja tässä kaikkein tärkein tekijä on avaruuden säteilyympäristö. Satelliitti ikääntyy siellä ja voi ihan jopa kuollakin. Ja me sitten tutkitaan sitä säteilyä ja kehitetään uudenlaisia menetelmiä suojautua siltä säteilyltä. Huippuyksikön taustahan on itse asiassa Euroopan unionissa, missä mä istuin monta vuotta semmoisessa komiteassa, joka miettii Euroopan tulevaisuutta ja avaruutta. Ja sitten kun tämä tilaisuus tuli tähän huippuyksikön hakemiseen, niin mä itse asiassa kokosin sitten maailman parhaat osaajat, jotka sattumoisin olisi Suomessa. Mehän ollaan tässä nostamassa ylös Suomen ensimmäinen tieteellinen avaruusohjelma. Ja jos me tehtäisiin tämä sillä tavalla, kun yleensä avaruusohjelmia tehdään, niin tässä menisi 30 vuotta. Mutta nyt kun me käytetään näitä uusia teknologioita ja piensatelliitteja, niin me toivotaan itse asiassa pääsevämme tähän täysmittaisen avaruusohjelman rakentamiseen vain 8 vuodessa. Ja koska kuitenkin puhutaan näin pitkästä ajasta, niin on tärkeää, että on tämmöinen pitkäjänteinen rahoitus tässä taustalla. Jos ajatellaan vaikkapa kommunikaatio, niin suuri osa siitä perustuu satelliittien signaaleihin, samoin navigaatio. Eli nyt tämän avaruuden kestävän hyötykäytön kannalta on tärkeää, että nämä radat pysyy käytettävinä myöskin tulevaisuudessa. Eli tämä olisi se kaikkein tärkein asia, mitä me halutaan saavuttaa.
The evolution of technology, like, it doesn't happen automatically. The evolution of technology and evolution of humanity, only happens if somebody does something about it. When you look at space technology as a whole, it's very easy to see that as the sort of next frontier of technology, next frontier of like humanity.
The globe has always been on the move. Until now, we really haven't been able to capture that continuous change that keeps on going in front of our eyes. ICEYE has developed a completely unique technology. It's a synthetic aperture radar system mounted on a small satellite and allows us to see through clouds and darkness any place around the globe. And that sort of data stream was unavailable before. The persistent monitoring that is available with ICEYE's technology it's the first truly global ability to look at things on daily and sometimes sub-daily basis. We can have hundreds of locations being imaged every 12, every 8, every 4, 5, 6 hours, and we can get that data stream to us continuously.
If you go from the scale of weeks to days or weeks to hours, you are enabling the idea of, oh my God, for the first time, we're actually looking at potentially predicting avalanches, potentially predicting volcano eruptions, predicting massive earthquakes, predicting building collapses before they happen.
You can't allow the ability to miss what's going on. How could we ever build a reliable flood monitoring system if we couldn't guarantee the ability to measure the water depth regardless of what's happening on the ground? What if we missed a flood? Then our system is worthless.
This is why we wanted to bring available what's called coherent ground track repeat. And we wanted to make it daily so that every day you can get a repeating ground track image acquisition from the same location that allows you to do these millimeter level change detection on every 24-hour basis.
It's a new way to observe the life on Earth because it's the first time that really we can reach anywhere and anytime.
DA Group is a technology company. We have been in space business about 40 years. We provide advanced electronics and radio frequency solutions and products for major space companies on a global scale. DA Group delivers equipment and subsystems for space applications, including all phases of development, design, manufacturing, and testing. We maintain strong prototype and in-house design. This enables us to provide unique and complex systems for the space applications. Currently, we are building systems for more than 10 satellites. We have a large clean room that enables us to provide large-scale manufacturing on the small satellites in series. Our aim is to make space everybody's business.
The world is slipping into post-factual existence. It's easy to make assumptions, take action, and go wrong.
I think there is no climate change at all.
I'm pretty sure I'll stop global warming if I stop using plastic bags.
I don't think there's such a thing as responsible forest management.
I'm not sure, but I think my food is produced organically.
Polarization of issues happen because of assumptions. We are on a mission against that. The technology we use monitors the environment from space. We collect and combine facts that you can use to start action. Our range of experts leverage creative technology to make an impact on things that really matter. Stop assuming. Try facts with us.
For many, it's the sense of freedom while soaring far above the Earth with the horizon the only boundary. But for me, it is something very different, the fascination of landing. When the Earth draws closer and closer, when the distant vision resolves into finer structures and vague outlines become distinct features, when ever smaller details are revealed to the eye. But in the world of the very small, where the human eye is no longer enough, we enter the domain of X-ray and CT technology. Here we make things visible that are 200 times finer than a human hair. Precision is paramount in the inspection of parts and materials, in their exact measurements. Minute defects can have big consequences for the safety of components. That's why every truck tire is X-rayed to make sure it's roadworthy. And every turbine blade intended for jet engines is examined inside and out. Our technology is used to screen the luggage of millions of passengers, and soon this inspection will also quickly and reliably identify what types of fluids travelers are carrying. This is where my colleagues and I are working to invent the future. A key trend in many industries is miniaturization. Far beyond where conventional measurement methods reach their limits, our computed tomography opens up undreamt of possibilities. We deliver razor-sharp 3D views of even the tiniest parts. All details can be measured with the highest precision and compared with CAD drawings, for example. Especially in the fast-changing world of electronic components, wherever greater performance must be packed into smaller and smaller devices. Our X-ray and CT solutions are integral to assuring that every part will be able to perform as specified. A crucial element in all this is the software. The best image quality is only made possible by highly complex algorithms. Yet for the user, the equipment is as easy and intuitive to operate as a smartphone. In the automotive industry, the limits of the possible are constantly redefined. And that begins right in the research labs, where new materials and manufacturing methods are tested. The tailor-made inspection and measurement solutions that I develop together with customers help optimize their processes, make their production more reliable, and save resources. No company can afford to design or deliver faulty products. It makes me proud to know that the largest and most successful companies in the world rely on our technology. Whether it's in the automotive sector or the aerospace industry, in electronics or medical equipment, the applications are practically endless. Seeing everything that's already made possible by our X-ray and CT solutions, I'm excited for the future. I'm eager to see what new worlds our technology will bring into focus next.
Interference-free satellite positioning is vital for the critical functions of society. Our researchers have developed a public GNSS signal quality monitoring service, GNSS Finland. This state-of-the-art system produces data that can be integrated to other situational awareness systems. Want to know more? Join us at our virtual meeting room.
We are living in a connected world. We are operating in a global economy. We are embracing digitalization in a fast-paced society. Communication, mobility, security, science.
Liftoff.
Life on Earth advances thanks to space technology. RUAG Space is the partner of choice for manufacturers of satellites and launchers across the globe. Enabling society to prosper, advancing everyday life. Today and tomorrow, we make it happen.
Harp Technologies is a Finnish SME company providing technology and R&D services in the area of RF and microwave engineering. Our customers are system integrators, equipment suppliers, research institutes, the European Space Agency and Defence Forces. We help our customers to develop innovative and competitive products, and we develop methods and technology to acquire critical measurement data. Our customers operate in the domains of space, defense and security, remote sensing, and IoT and telecom. Our activities are organized into 4 business lines: microwave sensors, microwave components, signal processing, and electromagnetics. In what follows, we present some sample equipment that we have developed for our customers. Within our microwave sensor business line, we develop radars and passive sensors and their subsystems for space, defense, and remote sensing. As an example, here is a passive sensor, a microwave radiometer. Radiometers are useful for various remote sensing applications. Within our microwave components business line, we design and develop components according to customer specifications. Here is one example, a low-loss ferrite switch. On the right, you can see how the switch works. The signal is first directed into one port, and after switching, into the other port. Within our signal processing business lines, we develop algorithms and technology to improve the performance of microwave sensors. As an example, here is a signal processor to detect and filter out radio frequency interference. The antenna is the key component in many radio frequency systems. Within our electromagnetics business line, we develop antennas for various applications. Here is one example, an antenna for the radar altimeter of a planetary lander. Harp Technologies provides technology and R&D services in RF and microwave engineering within 4 business lines. We support our customers in various application domains. Harp Technologies, at your service.
Space and its technology continue being a key element in our society development despite COVID. At both ESA and European Union, there are many missions directed to improve human being lives, Europe recently had its largest budget ever approved since its history, and there are a huge number of missions like Copernicus, Ariel, directed to explore exoplanets, and many others. Other countries such as United States continue investing huge amounts in projects such as Starlink, NASA supporting and leading many different missions, customers like Boeing, and many other organizations that are recurrent customers to Alter.
So Alter Technology, we have recently developed multiple self-service digital tools for our customers. So the most relevant one is a digital database for EEE parts that is based on big data technology. And then we have two digital tools that are intended for the customers to follow up on their purchase orders. Okay, so the first one allows them to check the whole procurement process so they can see information related to their logistics, the finances as well, and all the documentation of their orders. And then the second one allows the customers to perform the real-time monitoring of the testing activities. Then recently, we have developed a virtual platform, a consultancy platform that is intended for consultancy services. So then the users can send us their consultation requests for us to address them and give them the best solution.
Communication systems have become a key element in today's world where virtual events and virtual meetings take place worldwide. High-speed digital systems, microwaves, and optics systems merge together to meet the requirements of a growing demand for high-capacity links. Alter Technology combines its expertise areas to meet the requirements of future communication systems.
So space continues being in the trend, and Alter is just there.
As a leading space technology and intelligence company, Maxar helps customers unlock the promise of space to solve problems on Earth and beyond. Whether it's collecting geospatial data to help organizations build reliable maps for their consumers, providing the intelligence governments need for national security and sound decision-making, or building spacecraft components that will send the next astronauts to the moon and beyond. Our capabilities in space infrastructure and Earth intelligence turn big ideas into successful missions.
Time and time again, people have been gazing up at the night sky, looking for understanding and answers. But what if the answers might actually lie in the constellations staring back at us? Hundreds of kilometers away, small satellite constellations observe the whole wide world. Despite the distance, these satellites can be harnessed to satisfy our need for instant, reliable information and to benefit everyday life on Earth. Everything from national security to nature monitoring can be improved with space technology. We can now use remote sensing for blue-green algae monitoring in near real time, or rely on satellites to provide fast and robust communications during national security emergencies. At VTT, we believe space technology to be the answer to many of the pressing issues we face today. That's why for decades now, we've been working in space innovation together with our key partners, such as the European Space Agency. We have created the world's first hyperspectral cameras for small satellites and the first W-band millimeter wave radios operating in space. For us, it's not just about exploring what's out there. Our bold vision is to make space technology an integral part of the day-to-day life on Earth, with technologies like beyond 5G, hyperspectral imaging, and Earth observation. Want to join us in making a difference on Earth and beyond?
We have been on the far side of the moon. We have explored a comet and been in orbit around Mars. Today we are on our way to both Mercury and the Sun, and will soon begin our journey to Jupiter and 3 of its icy moons. At IRF in Kiruna, we have been developing instruments for space missions for over 60 years, and in that time, much has changed. The space industry is now open to many more stakeholders and is expected to grow rapidly over the next few decades. There is an increasing need to test and calibrate new space technology, and that is exactly what IRF Space Lab can provide. Space Lab is a constantly expanding facility with the aim of continuing to be in the forefront and to develop according to the growing market. As a step in this process, we want to broaden our network of customers and partners and share with them our knowledge, passion, and ambitions. Take the step out into space with us.
Harp Technologies is a Finnish SME company providing technology and R&D services in the area of RF and microwave engineering. Our customers are system integrators, equipment suppliers, research institutes, the European Space Agency and Defence Forces. We help our customers to develop innovative and competitive products, and we develop methods and technology to acquire critical measurement data. Our customers operate in the domains of space, defense and security, remote sensing, and IoT and telecom. Our activities are organized into 4 business lines: microwave sensors, microwave components, signal processing, and electromagnetics. In what follows, we present some sample equipment that we have developed for our customers. Within our microwave sensor business line, we develop radars and passive sensors and their subsystems for space, defense, and remote sensing. As an example, here is a passive sensor, a microwave radiometer. Radiometers are useful for various remote sensing applications. Within our microwave components business line, we design and develop components according to customer specifications. Here is one example, a low-loss ferrite switch. On the right, you can see how the switch works. The signal is first directed into one port, and after switching, into the other port. Within our signal processing business lines, we develop algorithms and technology to improve the performance of microwave sensors. As an example, here is a signal processor to detect and filter out radio frequency interference. The antenna is the key component in many radio frequency systems. Within our electromagnetics business line, we develop antennas for various applications. Here is one example, an antenna for the radar altimeter of a planetary lander. Harp Technologies provides technology and R&D services in RF and microwave engineering within 4 business lines. We support our customers in various application domains. Harp Technologies, at your service.
The evolution of technology, it doesn't happen automatically. The evolution of technology and evolution of humanity, only happens if somebody does something about it. When you look at space technology as a whole, it's very easy to see that as the sort of next frontier of technology, next frontier of humanity.
The globe has always been on the move. Until now, we really haven't been able to capture that continuous change that keeps on going in front of our eyes. ICEYE has developed a completely unique technology. It's a synthetic aperture radar system mounted on a small satellite and allows us to see through clouds and darkness any place around the globe. And that sort of data stream was unavailable before. The persistent monitoring that is available with ICEYE's technology is It's the first truly global ability to look at things on daily and sometimes sub-daily basis. We can have hundreds of locations being imaged every 12, every 8, every 4, 5, 6 hours, and we can get that data stream to us continuously.
If you go from the scale of weeks to days or weeks to hours, you are enabling the idea, oh my God, for the first time, we're actually looking at potentially predicting avalanches, potentially predicting volcano eruptions, predicting massive earthquakes, predicting building collapses before they happen.
You can't allow the ability to miss what's going on. How could we ever build a reliable flood monitoring system if we couldn't guarantee the ability to measure the water depth, regardless of what's happening on the ground? What if we missed a flood? Then our system is worthless.
This is why we wanted to bring available what's called coherent ground track repeat, and we wanted to make it daily, so that every day you can get a repeating ground track image acquisition on the same location that allows you to do these millimeter level change detection on every 24-hour basis.
It's a new way to observe the life on Earth because it's the first time that really we can reach anywhere and anytime.
As a leading space technology and intelligence company, Maxar helps customers unlock the promise of space to solve problems on Earth and beyond. Whether it's collecting geospatial data to help organizations build reliable maps for their consumers, providing the intelligence governments need for national security and sound decision-making, or building spacecraft components that will send the next astronauts to the moon and beyond. Our capabilities in space infrastructure and Earth intelligence turn big ideas into successful missions.
We have been on the far side of the moon. We have explored a comet and been in orbit around Mars. Today we are on our way to both Mercury and the Sun, and will soon begin our journey to Jupiter and 3 of its icy moons. At IRF in Kiruna, we have been developing instruments for space missions for over 60 years, and in that time, much has changed. The space industry is now open to many more stakeholders and is expected to grow rapidly over the next few decades. There is an increasing need to test and calibrate new space technology, and that is exactly what IRF Space Lab can provide. Space Lab is a constantly expanding facility with the aim of continuing to be in the forefront and to develop according to the growing market. As a step in this process, we want to broaden our network of customers and partners and share with them our knowledge, passion, and ambitions. Take the step out into space with us.
Space and its technology continue being a key element in our society development despite COVID. At both EAST and European Union, there are many missions directed to improve human being lives. Europe recently had its largest budget ever approved since its history, and there are a huge number of missions like Copernicus, Ariel, directed to explore exoplanets, and many others. Other countries such as United States continue investing huge amounts in projects such as Starlink, NASA supporting and leading many different missions, customers like Boeing, and many other organizations that are recurrent customers to Alter.
So at Alter Technology, we have recently developed multiple self-service digital tools for our customers. So the most relevant one is a digital database for EEE parts that is based on big data technology. And then we have two digital tools that are intended for the customers to follow up on their purchase orders. Okay, so the first one allows them to check the whole procurement process so they can see information related to their logistics, the finances as well, and all the documentation of their orders. And then the second one allows the customers to perform the real-time monitoring of the testing activities. Then recently, we have developed a virtual platform, a consultancy platform that is intended for consultancy services. So then the users can send us their consultation requests for us to address them and give them the best solution.
Communication systems have become a key element in today's world where virtual events and virtual meetings take place worldwide. High-speed digital systems, microwaves, and optics systems merge together to meet the requirements of a growing demand for high-capacity links. Alter Technology combines its expertise areas to meet the requirements of future communication systems.
So space continue being in the trend, and Alter is just there.
Jan, we can't hear you. Your microphone is off.
Thank you very much, Marius. So sorry for that break. So I was telling that welcome back to the main channel. The session rooms having a small extension. Still people are discussing their science topics there. And now we are preparing to start the last session of this conference. We have an interactive session with approximately 20 papers, a bit less, and we're going to have a session of 20 plus 20 minutes for approximately 10 papers at the time. But now we could discuss a bit how did you like the sessions and any technical problems you encountered which we still can probably solve. I was also creating a feedback form which is anonymous, and this feedback form is linked already to the chat. So if you open the chat and see there is a link, then this link takes you to a feedback collection form, and you can tell us what did you like and what you didn't like and how to improve and when to arrange the next one. But we will get back to this topic later on when I'm showing the closing slides. So any news from the sessions? And can you still hear me?
Yes, we can, Jan.
Excellent. Yes.
Yeah, I was hosting the biodiversity and climate session and everything went very well. No problems and everybody kept their time.
Which is always important. Yes. And what do you, by the way, think about this 15-minute format? It's very, very short, I agree. But on the other hand, it also makes the online presentation, which is sort of boring format by itself, a bit shorter and concise perhaps.
Yeah, I think it requires some tight moderation, but at the end, after some practice, I think it worked nicely. And even though usually there isn't much time for questions, but the conversation continues in the chat. So that's a nice thing in this online format.
Yes, and we are actually probably seeing only very small part of the conversation because people having a private person-to-person chat here. Any other opinions about the presentation format of 15 minutes online? Strong opinions either way.
Well, I could say that having done a presentation and the fact that it was only 10 plus 5 minutes made me actually focus on the big picture on the presentation, and not hang up on details and, well, important results which might be interesting, but if you only have 10 minutes, then you should only speak about the actually important stuff.
Yeah, but this is in every conference you should always talk only about important things, because if you think about the big conference with hundreds or thousands of papers, then nobody can remember them all. If you can remember one important thing from one presentation, you are doing very well.
Yeah, but if you are allowed 30 minutes, then you're going to or even 20 minutes, you will fill it up with the
I agree.
less important things. But when you're only given 10 minutes, then you really have to think, do I really have to say this? Do I really have to talk about this?
That is very true.
This shorter?
This is very true indeed. So any other opinions or feedback about the arrangements of the sessions so far? So the payload session was something which was a single session. So how was the payload session? Did you find anything new from payload session? There was a presentation about organs or organelles in space that was pretty exciting. So it's we don't see too much sort of medical presentations in these conferences, but if you see they are from another world and makes you believe that we can do anything in the future. And how was the biodiversity session? Did you solve the biodiversity sensing problems or?
Maybe not in this session, but at least we started discussing about it. But maybe the majority of the speaks were about climate things, and not really my expertise, but still very technical stuff, but still very interesting, as science always is.
Yes. All right. So I hope Suvi will soon close the rooms. We still have some people arguing in the sessions, and it seems like it's final discussions hopefully there. All right, so now we have the rooms ready for the interactive sessions. And as I said, the interactive session will work in this way that the presentations, what you see on the screen now, have a room number here as well. And every presentation is assigned to the room with a number enlisted here in the table. And you are actually already now entitled to join the rooms of these different presentations. We have very variable or topics here in the interactive session, and you can already join these sessions. I will keep this table online all the time, so you can come back, check the number of the next room you want to drop in, and then hopping out from this room and going to another room. And the presenters in the room, they have 20 minutes, now even a bit more, couple of minutes more. So you can go to these rooms and use whatever method you like online to present your work. And there is also a possibility to upload a couple of files, or we will list only one latest file to the schedule of the conference. There are already approximately 25 slide sets available for our participants. So you can later on also amend your schedule with additional files. So now I declare the interactive rooms open. I hope that presenters are here and presenting their work. It seems like in some rooms there are still nobody, but that's life. Then we have to just be happy with the abstract what we got, and you could join or enjoy the study on the general level. All right, the rooms are open and active. People are already there. So take a look. We come back here and start the next session of papers 16:50. So in 23 minutes. See you around. So I understand the discussion is still very much going on in the rooms, but according to the schedule, we start to change the presentations in the rooms, and next presentations in the rooms are listed here. So I make this one a bit smaller so you can see. So here are the next presentations, which are starting pretty much now. So go to the rooms and claim your time for your own presentation in the room.
Oh, I can't see my room or any room actually.
Yes, same, John. I think the breakout rooms are not active.
We have been bounced back.
Yes, it seems. You could continue the discussion. Huh?
Now they're open.
I mean, it's fine.
Were we the only room that was cancelled, or was everyone thrown here?
Yes, everyone was thrown here, and now the new rooms have been appointed, started.
We were mid-sentence.
Yes, we do. Actually, I'm one of the admins. I'll go ask them. Just a second.
Yeah, we just closed the rooms and reopened them for the next sessions.
The next session is on, which means that we might be we might be intruding on someone else's presentation.
Yes, basically that's the end of those sessions, and the next sessions are beginning. That's the reason.
Yeah, because if we continued in one, then we will be introducing in someone else's section. But I mean, if you want, I can continue answering your question here, since we're not in the room. We're just in the limbo.
Sure.
We're in the limbo space, as I called it.
Keep going.
Can we?
No, I was just going to say we've had these discussions now extensively in various working groups, international working groups, looking at not just debris, but also, again, the night sky and whatnot. And there is an awareness that creating an international treaty will take forever. It will take much too long. So there are two things that we see happening right now. One is that, as we know, different countries, I'm not visible. Yeah, different countries have implemented their own legislation to look at commercial activities, and US, Luxembourg started this, and of course then Japan, UAE followed. And in law, if one of the, I can call it pros and cons depending on whose side you're on, if there's enough countries creating these new laws on commercial activities, then we're moving towards what we call customary international law.
Yes, but to go back what you just mentioned, is it the case that there is interest in the United States to make law regarding or controlling somehow the like space debris?
Yes.
That's a major win there. Like that's almost halfway win.
At least there are individuals. Mind you, by the way, I'm not American, I'm Canadian.
Yes, but you are aware of the
Finland, and I live in Finland. But
you are aware of how the
no
things going on.
It's there are many different voices, and so but there are voices arguing for this. Actually, Kevin O'Connell, who's one of the team members at the MIT group, he works for the he used to work for the commerce sector in the States, and so he's been one of the people very vocal that there is a need for new regulation in the orbital space, and for especially with respect to the private sector. But there is no consensus at the moment. There is no consensus. There's no consensus at national or even international level. And as you know, US proposed, or not proposed, but already passed the Artemis Accords, which
actually I don't know. What are those?
Well, you don't know.
No.
Okay, so US has passed via NASA passed the so-called Artemis Accords, which are meant to be a series of bilateral treaties. So it's kind of like what China is doing with respect to Belt and Road. I'm not talking about commerce, but like trade and commerce. So like.
Yes, I know exactly what you mean.
You know what I'm talking about. So it's not
Yes.
like a multilateral big treaty, but they're going to sign individual treaties. They've already done it with the UK, Canada. Can't remember. They're like eight countries or more now, probably growing. In the context of Canada, a colleague of mine actually, there was this brief moment where Canadians, they said, we are going to consult the public. And so he wrote a small op-ed on Indigenous people's rights, for instance, which didn't really affect anything. But yeah, so the thing is, it's not a multilateral proposal. And obviously Russia and China and some of the other powers are not in agreement. But then, if there is sufficient number of these bilateral agreements, we're going towards that kind of customary law, that they're creating a new parallel instrument as in parallel to the Outer Space Treaty.
Yeah, and if the situation is that major Western countries have these signed these treaties, and then it makes it so that businesses or companies who operate their space assets not in accordance to those treaties cannot conduct business in those countries, then it just kills them. it's as if they were part of it, because it's not viable business for them anymore.
Yeah, but there's another. But another thing is that OST is still what people. So I'll present one. Maybe this will explain the best. There is one what I identify as kind of a debate in the world of outer space law right now. There's a group of people who are saying we have nothing and we need to make all these new laws because we have nothing. But then there's another group, which includes me, that says that we do actually have all kinds of instruments because international law as a whole does apply to outer space. So outer space is not like literally outer space, because there are human activities in there and there are rules and regulations and they all apply. Yes. So if we're talking about something like liability, safety, environment, there are instruments that we can tap into. It's just that more work needs to be done to make this kind of visible. Because for a very long time, outer space has been somewhat neglected in the international legal community and continues to be so, actually, especially in academia. But yeah.
Okay.
Sorry, I'm trying to speak over this calming music. But yeah, I hope this kind of helps a bit. But it's a process, and it's a bit of an uncertain process. Okay. I'm not terribly positive, but I'm trying to.
Okay.
All right.
Yeah.
Pedos.
Nothing. The main organizer just came and snapped a photo of us.
Oh, okay.
Yeah. I guess the other breakout rooms are going on at the moment also. Yeah.
I don't know. We were the only ones. No. But where's everybody? There's only 38 people in this big environment. So
yeah. So if you want to join the other rooms,
join another breakout room.
Yes.
Exactly.
Okay.
So if you want to join the sessions that are currently on the slide,
yes,
then please find your room.
Thank you.
You are. Your name was Elena Chirkovich.
Yes, that is
okay.
Fine.
Yeah. Okay.
I was in room 1, but I looked at for some reason I clicked on room.
Okay. But that's an interesting take on the legal side of like space debris.
It's well, I mean, actually, just in 2 hours from now, I have a meeting with a working group that is supposed to. UN COPUS just started a new consulting process, and there are different working groups that are going to provide some input. So we're having a meeting in 2 hours to solve all the world's problems.
Oh, okay.
All right.
Or at least this problem a bit.
Well, at least this problem, yeah.
Yeah. Okay.
All right.
Interesting. And it seems that the situation is not as bad as one would think.
Well, it can be bad. I mean, the space debris is already bad. It's just that I think there needs to be a combination of awareness and then action. From an academic perspective, as I don't work for the government or anything like that, but I think that, but someone who's been in international law for a very long time, international legal scholars still think that outer space is, I don't know, something about Yoda. And so there is a bit of that disconnect, Yoda as in Yoda from Star Wars. So there's a bit of a disconnect there. And I think that needs to grow, the awareness that outer space is indispensable for the Earth system.
That's kind of worrying, because I would have understood that kind of viewpoint like 20 years ago, but now it's because traditionally that section of international law was allocated for issues like security, cybersecurity, and military. So most of the departments and universities are like looking at starting from that perspective. Very few, and this is because I've been working on this research project since maybe 5 years ago. And when I started talking about the Earth system and outer space in 2017, it was just as if I was speaking in, I don't know, ancient tongues or something like that. It's not, for some reason, it's taking, there is, it partially has to do, I think, with popular education on this topic. It's seen as something very niche. You know, certain people do outer space. It's the science, the nerds, the geeks, whatever, you know, it's a bit like that. And it's when you go to just a regular international law conference and present on outer space, it takes really a long time for people to kind of say, okay, so this is why this is important.
And legal people are, seasoned lawyers.
It's as if what we need is a popular TV series that has Kessler syndrome in it.
Yes, actually.
That's what we would need.
Maybe we can get the funding from Finnish Cultural Foundation and start a Finnish series. But yeah, no, you're right. It is at that level, actually. Or at least I would argue. So we need kind of education as well in schools and outreach, and that's what we've been arguing for now. But we need money for all these things, So anyway, I will go and see if I can catch one of the.
I think I will too. But
yeah.
Interesting chatting.
Same.
So, welcome back, and I think our session has ended and most of the people have been getting back to the main track and main channel. So we don't have anything else to do than wrapping up the whole conference. Can you hear me? Can you see me?
Yes.
Yes, we can.
Excellent. So I will
we can.
open my last slides. It takes a bit of time. So wait just a moment. So, Finnish Satellite Workshop 2021 approaches to the very end. We have been exhausted our program. It has been days filled with science, presentations, questions, arguments, and so on. So, wait a moment, I still don't get my slides where I will put them on right now because I really want to show you a couple of things of this conference. So technical problems are not uncommon in this kind of setup. So here we go. But first I would like to thank all our industrial partners. Without industry, we would have been not able to do this event. And that means that the industry has been paying their entrance to the conference, but all the rest, the whole scientific community has been enjoying the conference for free. So if you want to have a short peek to behind the scenes, how this conference was coming about, here we are, the conference team, Marius, Markus, Suvi and Jan. So we were bringing the conference online. Some smaller duties were also in different other places. We look at the statistics, then the registration of the conference was reaching around 830 people all around the world. We didn't got anybody from Kazakhstan, we didn't got anybody from China, and there are many African countries and some South American countries which were not presented, but we had a very global coverage of this conference. I was checking also what kind of statistics we had in the Zoom meeting. So more than 1,000 participants in the Zoom was participating. We had 1,000 people licensed. It was well used. And I think that some people were following the sessions with 2 different devices in order to have it all, which is very good. We had around 125 presentations. We still don't have the final count as we don't know who was in some sessions missing the slides, but mostly all the presentations were given. Slide sets, approximately 30 uploaded slide sets can be already found associated to the schedule of the program, and I encourage all the presenters to upload something about their presentation. This makes a nice footprint for the future. We had also 23 companies and several organizations who were supporting the event and having and gaining some visibility during the event. And as I said, we had more than 1,000 documented visitors or participants in the conference, and this is the all-time high for this conference. Starts to be already quite a meeting. So if you want to give us a little bit of feedback, what should we do next year? What should we avoid? What should we improve? So there is a link. Link is also in a chat channel, so you can click the link and give us feedback. Feedback is totally anonymous, so you don't need to associate your name with your feedback. If you like, of course, you can type your name also to the feedback, and we are gladly getting back the greetings. And finally, I declare this science event, Finnish Satellite Workshop and Remote Sensing Days 2021 closed. Wish you all the best, and say that stay safe and keep building space missions. We're going to need them for many different purposes. And thank you very much. So I think what we can have now is a free discussion. If anybody has anything to say, we will open the discussion rooms again. If somebody wants to discuss with somebody, I don't know what, but there might be different kind of topics to discuss. And I will also end all the recordings right here. So thank you very much, and the floor is open for undocumented feedback and discussion if you like.